ভেরিয়েবল এনার্জি সাইক্লোট্রন সেন্টার ভিইসিসি হল ভারতের পারমাণবিক শক্তি বিভাগের অধীনে একটি গুরুত্বপূর্ণ পারমাণবিক বিজ্ঞান ও প্রযুক্তি কেন্দ্র।
Ladies and gentlemen, greetings to all of you in this session of celebration for GAE iconic week for Azadi Ka Amrit Mahotsav. This whole week is going to be not only very eventful, but also full of new experience to all of us, and we hope that today's program will not be lectured by eminent scientists and archaeologists, followed by a culture program, is surely going to make this day memorable for us. To start with the program, I request Dr. Vaishali Naik, chairperson of today's event, for a welcome.
On behalf of the organizing committee, a very warm welcome to all of you. On the third day of the iconic celebration of Azadi Ka Amrit dignitaries, colleagues, and students, as we celebrate 75 years of our independence, past the recent devastating pandemic and uncertainty, the war in the neighborhood, all of us are looking forward to glorious next 25 years with hope and diligence as we move towards the centenary celebration. So, it is most appropriate that we also look back to our history for lessons from it. As all of you would agree, history, when scrutinized with solid scientific proof, becomes undeniable evidence. So today, we are glad to have with us eminent scientists who are masters of this field. Professor Anindya Sarkar, a well-known geophysicist from IIT Kharagpur, and Professor Vasant Shinde, celebrated archaeologist from the famous Deccan College in Pune, will take us through their journey of the Indus Valley Civilization. We shall be ending today's lecture on a musical note with the performance of music by Madhav. Once again, I thank all of you for joining us and also thank the speakers for kindly accepting our invitation. I now hand over the dais to our director, Dr. Sumit Som, and request him to do the honors of chairing the scientific session. Dr. Sumit.
So, on IIT Kharagpur, when you had this job, for that, that's the thing about me. That's something. Professor Anindya Sarkar, the now says, defending the head of the department. Completed PhD from Physical Research Laboratory, Department of Space, Hyderabad. Sarkar has established country's first it's a large scale natural facility. Major research interests application of technological archaeology, sedimentology, archaeological sequence, stratigraphy, color, order, sediments, also variability to discover short geological components. Causes of extinction events for major geological boundaries. Sometimes there are several hours. So, sometimes just yeah. So,
I must thank Professor for this lecture. And I also thought I must tell candidly that I am not a geologist. And broadly, I work in the present and past climate change. And operate as an investigating geologist. I'll be telling you that what drove me in this field and why I thought that so such a later part of the field. Now, if you look at, for example, uh, uh, the geological time scale, you know that I would be confining to, let's say, only last 2 million years. That is the time when basically the genus Homo appears as a carnivorous scavenger, hunting, gathering started. And then there was a series of evolutionary changes of the Homo. For example, the Neanderthal appears, the invention of the clothing, uh, some kind of very elementary level language, sophisticated cognition, and then it goes on. You have the uh, very early cultivation somewhere between 12,000 to 9,500 BCE. Uh, Early farming, cultivation of barley and wheat, for which the evidences are found, especially in the Pakistan region uh, and some part of the Middle Eastern countries. And then, of course, you have the so-called Chalcolithic phase start. Incidentally, you just add around 2,000 years, so 2,700 means geologists, we always want to talk in terms of before present. Archaeologists want to talk about, before common era. So you have the first Mesopotamian writing, Stonehenge construction, if you go to the England, you will see. And then comes very extensively contemporary several old world civilizations, including the Indus Valley civilizations, when the mankind for the first time started building the cities. Okay, and from there on, you enter into the Iron Age, went with rivers, and then you enter into the classical, medieval, and the modern histories. So this time span, you know that this is a spectacular time span in terms of the events you consider. The art had developed extensive polar ice caps, which you see today, for example, Antarctic and Arctic ice sheets. And there are also changes in climate in a very major way. Okay? And this kind of rapid evolution of the Homo sapiens always provoke people to probe that whether climate had anything to do with this human evolution. Because you must understand that from somewhere here, hunting gathering system, to go to building the cities, it requires certain evolution of the brains. And many anthropologists have always conjectured that probably climate can be a triggering factor, thereby you accelerate the evolution of the brain, and therefore a variety of activities mankind start doing. But this time period, geologists have been studying from a different angle. Purely from academic viewpoint, they were studying it for knowing the climate changes, what was happening here. For example, I just give one example. This time period, somewhere around 10,000 to 7,000 years before present, we had a very warm Earth. Okay, the relative sea level was much higher, and that is the time when the mankind started, spreading, migrating from one continent to the other, and whole lot of things happened. So geologically, we call this period, the lower part we call it the Quaternary, and the last 10,000 years we call it the Holocene. So that is one driving part, because I have been working in this time scale purely for climate studies over the last 20, 30 years. But that it also kind of overlaps a coincide with the human evolutionary traits, also led me to probe that why not try to see some of the old human settlements, and also simultaneously try to understand the climate from different archaeological settings. So that was one driving or motivation, you can say, for studying these times. The other one is, of course, is a bit societal problem. That if you look at not only in India, if you look at this ancient time, people have conjectured many things. Okay, in the sense that it's not only confined to India alone. If you go to the US, there is a lot of people believe that Darwin's evolutionary theory is welcome, and the creationism was the kind of thing. Okay? So India is no exception. For example, you have hard time finding in the newspaper that there are claims or there are kind of quasi conjecture that India had ancient Indians knew how to construct fabricate aeroplanes, and aeroplanes in Vedic age could fly planets, and the conjectures like that, the Vedas could be somewhere 6,000 BC, 8,000, 9,000, 10,000 percent. And as just now I have told you, that was a time period when basically mankind was a hunter-gatherer. So the pushing the Vedas 10,000 years, which is when the language even was not properly trained. These are the things where, in a way you can say that that there is a blurred boundary between mythology and the science. Okay? So therefore, these two, motivations. That one is that a time frame which is very conversant to me as a geologist, that this is the time frame where I was studying the climate, and then these that if some of these human evolutionary traits can be studied from scientific angles rather than
some kind of conjectures and or ground. And today's archaeology, not just gone, it has come a long way actually. And today, as you can see, this is a very famous journal of archaeological science, where the archaeologists use or the scientists use almost all the modern technologies what is available under the roof. Okay? Let me just give you few examples. How does one unravel the mystery of the past? Okay, this is a few years back there was a large megapolis which was unearthed below the Guatemala jungles, which is now dated to be somewhere around 4,000 years. So this was completely covered, and nobody knew, okay, that such a magnificent city was megapolis was there. And how did they discover? They used basically a technique which is known as the LIDAR, that is light detection ranging survey. Uh, I will. I'll be happy. Okay. Uh, okay. So this technique is actually used conventionally by geoscientists, geographers who are studying, for example, the landforms, various kinds of subsurface structures which are available in the earth. So this was a standard technology, airborne technology via GPS, which they were using in other fields. And this technology is now being very extensively used for studying what we call the archaeology also. The other one is that the conventional archaeological field, that is the excavation as the archaeologists do. This is, for example, the archaeological mound at Vida. Okay, as you can see, this was the mound before excavation, and as they are excavating, they are gradually unearthing the city. Okay, I'll be discussing about this in a very great detail. So, and once they find out such kind of human settlement, they start excavating below. It's a very time-consuming job, labor-intensive job. It requires a lot of money. For example, the Indus Valley city, Dholavira in Gujarat, the excavation they started in 1990, and it went for almost 15 years, okay, to unravel this. So you can easily imagine that in the earlier part of the century, the discovery of the Harappa and Mohenjo-daro, you go to the history, they took nearly 20, 30 years. Even now the excavations are going on at selected places. Now, what you do once you find out an archaeological remains, the first thing one would like to know that how old it is. And you utilize very conventional what you call the radiocarbon dating process. Okay? If the cosmic rays are hitting the nitrogen, they are getting converted to potency at about 5,000 plus half-life. It gets decays back and it enters into the food chain. For example, these are some of the carbonized cereal from Indus Valley Civilization, the wheats or the rice which have been completely carbonized. And then these radiocarbon can be measured by accelerator mass spectrometer today. This is a physical research laboratory accelerator mass spectrometer facility. And this has been our kind of backbone for generating the radiocarbon date at different Indus Valley Civilization sites. Okay. The other way, now sometimes one is not that lucky to get, for example, the cereals. Okay? You may not get always. Okay. So, but still you need dates. So how do they date this? What you get in archaeological remains, like as it is shown here from Sanauli, UP, you also get what you call this kind of potteries. Okay, this kind of potteries. You see there is a skeleton, you get this kind of potteries. Now these potteries are made, as you know, today if you go to the people who make these pots, they fire it at a high temperature. And that actually gives us a tool which is today known as optically stimulated luminescence dating technique, which basically uses the counting electrons trapped in bond artifact, and essentially by which you can, what you can do, you can tell exactly how much time elapsed since this pottery has been made. So wherever you get the cereals, like what I told you, date them. Wherever you get these potteries, you date them. Sometimes you do not get either of these, you try to date something else. For example, the animal bones or what you call the human skeletons and things like that. Today I will be principally focusing uh, on use of isotope tracers in the archaeological sites. And when you say isotope is a big field, this is the center of studying isotope. I will be talking about mainly the isotopes of lower masses. Okay? For example, the oxygen, hydrogen, nitrogen, carbon, sulfur, and things like that. And even there, if you look actually, you see that they have a vast applications. For example, you can study the planetary evolution by using isotopes of oxygen and hydrogen. You can do oil exploration by studying carbon and sulfur isotopes. You can study climate change by using oxygen and carbon isotope. Medicine, for example, very extensive use is found in medicine using of oxygen and hydrogen isotope. In agriculture, you have nitrogen and carbon because they are taken up by the plants. They can be fingerprinted very nicely. And of course, the forensic science, nitrogen, oxygen, and carbon isotopes are used extensively. And then the same technique which forensic science actually use are also used in the archaeology. So what I will be principally concentrating today is neither nitrogen nor the carbon, because they essentially talk about the food and the evolution of the dietary behavior of the animals or the human being. I will be principally concentrating on isotopes of oxygen, which we use as a principal tracer for understanding the evolution of the ancient settlements. Now, this is a like a detective fingerprinting. Okay, if you go today to Washington D.C. And go to the FBI office, they have today this kind of mass spectrometers which measures oxygen and hydrogen. Why do they do it? This is a case of the mystery of Little Miss Lake Pans coffee. A small girl was found killed in the east coast of USA, and the police was trying to find out where from she comes. And then what they started doing, they started analyzing the teeth, they started analyzing our hairs and things like that. And that those teeth and hair and the isotopes in them actually contain the information from where the person came. Okay, how you may be wondering that how that can happen. Principally they use a variety of mass spectrometers. These are some of the mass spectrometers in our lab at IIT Kharagpur, where we study oxygen, carbon, hydrogen, nitrogen, and sulfur isotopes. And it can tell you a lot about climate, vegetation, migration, including the human migration. And simultaneously, we also do chronology by using isotopes of varying half-lives, depending on your problems. You are going back to a million-year time scale or billion-year time scale of planetary evolution, you use isotopes something like these, which are 4.5 billion years old. And if you are trying to look at processes which are very short-lived processes, you use this kind of isotopes. So these are basically our very super clean rooms and radiogenic isotope laboratories. So we analyze all these materials there. And in archaeological perspective particularly, what are the samples we get? As I said, that just like forensics, we get bones. This is a skeleton which has been found in one of the Indus Valley Civilization sites. You get teeth, you get snail shells like this, which is basically calcium carbonate. And you can go to time depth from million years to basically recent. Okay? And this is basically a deer teeth, and this is basically a cattle bone from a place called Tirana. I'll show you one or two, some data which I'll show you, which might be interesting. Now, if you look at the bone, bone is a composite material, that it has about 68% hydroxyapatite, and as you can see that it has carbon that actually contains the information what this animal was basically eating. But we are more interested in the oxygen, okay? And that is what we try to extract. And particularly the phosphate being a very, very tough radical, so a whole lot of chemistry has to be done so that you extract the oxygen, convert them into gas at a very high temperature burning, and then you can study the isotopes of oxygen in those phases. In addition to that, as I said, that you can also analyze calcium carbonate, which also contain carbon as well as oxygen, and you can use them for variety of processes. Okay. So summarizing, let me just summarize that what isotopes can do. If you want to study past climate, isotopes, yes, can be used as tracers. When you say past climate, what do I mean? If you talk about the modern climate is a very complicated system. For example, if you look at the monsoon system, it not only involves temperature, sea surface temperature or land temperature, not only it involves, for example, the amount of rainfall that is taking place, but it's also very intimately connected to the wind stress, wind speed, geopotential height, whole lot. And that is why, the Indian Institute of Tropical Meteorology, they have to have a supercomputer to predict the monsoon, okay, onset and when the monsoon is basically returned. In the past, we do not have that liberty. We cannot get so many parameters. So what we can do, we can at best can get idea about rain, how much rain was taken, rain was there, or if rain was not there, there was a drought. Or we can talk about the temperature, that at what temperature any organism was living or a mankind was living. And of course, you can talk a lot from carbon and nitrogen about the paleo diet, okay, what we were eating in the past. Now, let me just give you one cartoon, show you one cartoon that how isotopes get, fractionated, okay? For example, when we talk about the oxygen isotope, there's 3 isotopes. One is 16, and then it's 17, and then it's 18. If you look at the abundance, the 17 is a very small abundance, okay? It's extremely difficult to measure, okay, in natural system, okay? Although in our lab, we have been able to measure now even that, and that is another dimension. But conventionally, people study these isotopes, oxygen 18 and oxygen 16. One is heavier, another is lighter. Now, when the evaporation takes place, obviously, the quantum mechanics demands that the vibrational frequencies are such that the molecules which are going into the vapor phase, they will be concentrating more lighter isotopes compared to the what you call the liquid phase, which is heavier and left below. So what happens if you start with a value of 0 and the notations of isotopes are such, we explain them in terms of delta, which is nothing very great, which is the heavier to lighter isotope ratio with respect to a standard. What standard? It is the International Atomic Energy Agency at Vienna. They supply to all the laboratories across the world and they use it as a standard. So this delta value, if you just take, you see that this becomes 0 becomes minus 10, essentially meaning that it has concentrated more of 16 ohm, okay? And this vapor, when it is moving towards the continent as it is happening now, for example, in the monsoon time, that the moisture from the Arabian Sea or the Bay of Bengal is lifted up and then they are dragged towards inside the continent. So it keeps on raining. Now again, when they are raining, there is a phase transition. So there is a vapor to solid, liquid phase. And then in the liquid, correspondingly, the heavier isotopes fall. And the remaining vapor becomes further concentrated in lighter isotopes. So this unique, very simplistic picture tells you that by using isotope, you can do 2 things. One is the fresh waters isotopically are much more negative, okay, because it has much lighter isotope concentration, okay. And the marine waters, they are much more enriched, okay. Just the reverse happen if you have an evaporation. So if you continuously evaporate, the lighter ones will go out and the heavier ones will remain. For example, if you go to the hot desert, there are some saline lakes. Those lakes will be heavily concentrated by, will show heavy concentration of heavier isotopes of oxygen. Now, by the time you reach here and go to the mountains, you get extremely negative, fallout of these rain. And when you go to the, for example, go to the top of the Himalayas, those rains get converted to ice. So therefore, the ice itself is an extremely negative kind of values you will be finding in terms of the isotope systematics. So whether you go to the Antarctic, whether you go to the Arctic, or whether you go to the glacier ices are extremely negative in terms of the what you call oxygen isotopic composition. The fresh waters are little more positive, and ocean waters or evaporative waters are extremely positive. So it gives you a tool to differentiate, the kind of water which was there at a particular place, which any organism or any mankind was either drinking or was living in. Okay. So just to show you one animation, this is what you can see, the monthly weighted oxygen isotope throughout the globe. This has been mapped by many people. The International Atomic Energy Agency, they have the measurement stations at different places. We have in India, we have two places, where one is at Bombay, one in Delhi, and they have been measuring for last 60 years the isotopes of oxygen, and therefore they have been able to generate this kind of map. What it shows you that even at monthly scale, the scale is from -2 to -30. And remember, our experimental precision in mass spectrometers are 0.1 per mil, or better than 0.1 per mil. So it's a large variation, as you can see, you are finding on a monthly basis globally. So each area is characterized by a specific isotopic composition of water. So when I was talking about the little kid who was murdered and whose body was found in the East Coast, eventually the FBI investigated and they found out that she actually belongs to the West Coast, because the water in the West Coast of US is completely different compared to the water in the East Coast of the United States. Here also in India, the water which is there in Rajasthan, which is an arid area, highly evaporative area, where the rainfall is very low, is quite different than the monsoonal areas like Bengal or Bihar or the same. So that is the kind of very basic idea by which we use. So how does it work? You have mammalian bone, tooth, or calcium carbonate, delta 18O, and this delta 18O is equal to the drinking or ambient water oxygen isotope, and drinking or ambient water oxygen isotope essentially depends on the rainfall. Okay, and this mammalian bone, tooth, or shell oxygen isotope essentially talk to you about the rainfall conditions. Okay, and by this pressure you can even kind of quantify also that how much rain had taken place in the past. Okay, but remember one thing, that when you are analyzing a bone or a skeleton, a man lives, say, let us say 60, 70 years, a dog will be living 10 years or so. Whatever skeletons you get in archaeological remains, you will be getting a kind of integrated rainfall information at that place over its lifetime. So it will give you a rainfall information for 100 years or 10 years or something like that. But what if I want to know at the seasonal scale? Okay, that I want to know that, let us say 500 years back, how the season was like. Okay, for that you require an archive which can record that seasonality, and also you require an experimental technique by which you will be able to differentiate that seasonal variation at a very micro scale. Okay, not a very easy job, but still people started doing it by analyzing a variety of systems. One of those are something like this. This is what we did very recently. If you, at least Bengalis would be knowing, if you eat a fish, the fish has a ear bone. Okay, fish has a ear bone. Okay, especially if you eat VECC fish, it will hit your mouth. So it has a ear bone. That ear bone would be hardly half a centimeter. Okay, and if you make a polish section, you will see these growth rings. Okay, and that growth ring means that when the fish was born or in the juvenile stage, it started its life here, and as it grew, these were growing like this, almost like a rings of tree, almost like a rings of the coral. The same thing can be done. But remember that this is a very small dimension. So therefore, we could not have done it physically as we do for a bone or things like that. A bone is a big material. So I can drill, I can take the sample, I can do whatever chemistry I want to do. But for this, it would not have been possible to do that, because it itself is so small. And if these layerings are essentially indicating some kind of climatic perturbations, so there was a technique necessary for developing at that micro scale. And that is what we had developed over the last 2-3 years at IIT Kharagpur. We have been able to use laser, CO2 laser, which has a beam of something like 50 micron, So it can analyze a large number of samples, and thereby it can retrieve the climate during the lifetime of a fish. So if a fish is living for 2 years or 1 year, so you can talk about the seasonality during the existence of the lifetime of the fish. And why fish? Because many of the archaeological sites, they have this kind of fish remains. They are typically, conventionally, the fisheries people call them as otoliths, and they are found plenty because the ancient settlers, they were eating this kind of materials, this kind of fishes very frequent. So you have this kind of layerings. Okay, when you analyze it, you get this kind of wriggles. Okay, this is from an Indian Ocean. As you can see, if you look at the temperature of the Indian Ocean, it varies, in winter time, 28 degree to something like about 30, 31 degree. So there is a distinct seasonality. Okay, you can see that October and so on and so forth. And these temperature is actually recorded in these, shell materials. Okay, in these shell materials. So this is a this is a laser system at IIT Kharagpur, which we use almost on a daily basis to determine the seasonality of it. So basically, my point is to tell you that you can talk about a annual level climate, you can talk about decadal level climate, you can also talk about seasonal level climate, depending on what is your requirement. Okay, what is your ultimate goal. Now, let me just take you through few journeys of where we have applied these techniques. Okay. Now, many of you must be knowing, those who are interested in history, that if you go to Mediterranean region, we had what we call the so-called Assyrian, kingdom, the Babylonian kingdom, and things like that, the Egyptian kingdom, and all this. Okay, and these empires, people were very much interested for a long time. That you have a Persian Gulf here, you have a Mediterranean Sea here. Okay, whether they had any kind of connections, there were trade exchanges or not, whether there was a maritime trade, whether the trades were coming from Persian Gulf, whether the trades were through the routes of the Mediterranean Sea. So this was one of the questions which apparently archaeologists have much interest in. Okay, and that is why the University of Haifa, actually, when they approached us, we were very happy to collaborate, because by that time we had developed the technique. And this is the tail door, which is the coast of the Israel. This is the archaeological sites. Okay, the archaeological sites in the Mediterranean. Now, when they were excavating these, they find this kind of fish teeth. You find this fish teeth even today, but they were using it in the ancient time also. Okay, and we extensively studied the isotopes of these, and eventually came to a conclusion that this tail door site was trade-wise connected both with the Persian Gulf and with the Red Sea via the Mediterranean. Why? Because the salinity or the freshening of the water of Mediterranean, Persian Gulf, and the Red Sea are completely different. Okay, so therefore, each having a distinct origin, and the fishes which were being taken from here, they were taken from here, taken to the tail door, or sometimes from Red Sea, taken to the tail door, and one can very nicely actually talk about this trade. Okay, this is just one of the tracers which I mentioned. There are many isotope tracers by which people are trying to study what we call this kind of connection of the trade. This brings to the main topic today, which is the mysteries of Indus Valley civilization. Now, we typically call them as the Bronze Age civilization. The typical age is 5,500 to 3,500 years to present. But I must also tell you that you had some old world contemporary civilizations. For example, Yangtze River in China, you have the Egyptian civilization, Mesopotamian civilization, and so on and so on. Almost contemporary civilizations. Okay. Now, what was the reason that this civilization came into existence, and what is the reason that the civilization suddenly collapsed and disappeared from the earth? Okay. This is a mystery which people have been asking for trying to probe for a long time. Many theories have come up. Okay, last 50 years. One of the theory was the prolonged drought. Other could be interpersonal violence. Okay, the people found that large graves and cut marks in the what you call skeletons, or even sometimes, infectious disease has also been invoked for elimination of these civilizations. Many things have been suggested, okay? But none of these theories actually can kind of completely or conclusively say that this was the disease, okay? So what did we do about 5 or 6 years back? We wanted to go to a archaeological sites of Vienna, and this is what is the, when the excavation was going on, where it occurs somewhere here, okay? It occurs somewhere here. This is your Harappa, okay? This is your Mohenjo-daro. This is the Indus River. That is why the dots are nothing but the civilization sites, big settlements or the small settlements. The Vidana is here, Rakiguri is here, on which Dr. Sinde is going to talk today. And interestingly, as you can see, this all around the periphery of the thought design. All around in the periphery of the thought design. This was a place which was excavated long back by archaeologists of Archaeological Sites of India. And they kind of predicted or tried to tell, based on the archaeological evidences, that this could be very old, even older than contemporary civilizations known elsewhere of the Indus Valley settlements. Okay, so as I said, that is something like 5,500, 5,300 years of things like that. So we went there, but unfortunately, this site was excavated, it was covered. So we had only the materials. We had only, for example, these potteries, we had bones and things like that. And we could never have the access of collecting the samples as the excavation was going on. But nevertheless, let me tell you what we found out. This is a monsoon record from the Arabian Sea. Okay, this is a monsoon record from a lake which is very close to the settlement of Pirana or Rakiguri. Okay, the lake where they drilled and they found out. And this is from the archaeological site itself. Okay, first thing we did, as I do always, that I go for dating. Okay, because not many dates were available. And when we started dating, we find that conventionally, if early Harappans or the early Indus Valley people started their habitation around 5,300 years, this is a place where probably the early Harappans would be as old as 8,000 years. Okay? That is the kind of things we got. Okay? And instantly, it looks that probably this conventional idea that everywhere the Indus Valley civilization has to start at 5,500 years may not necessarily be true. Brings to a question that whether the cultural evolution is time diachronous or time synchronous. Okay, most likely it should be time diachronous. I don't think that it appeared all at a time. It could collapse all at a time, but it appears all at a time. In the biological world also it doesn't happen. Okay, and in human evolution and things like that also it is very unlikely. Anyway, now this early Harappan time, the blue shaded region, is basically a time when the monsoon was very strong. That is the time when the Harappans came into existence and they started building the cities and things like that. But as the time progressed, the monsoon started going down. The lake level, for example, was very high. The lake level started going down and suggesting that probably the monsoon over Indian subcontinent was slowing. Okay? It was going down and down. Interestingly, although the monsoon was going down, but you can see the Harappans who are basically continuing in their endeavors, going through early mature Harappan to the mature Harappan when major cities were built all across the subcontinent. Okay? Meaning what? Meaning that these Indus Valley people could survive in spite of a decreasing monsoon over 1,000-year time scale. Okay? And they did not disappear just like that. And the question obviously brings that what could be those factors that led them to sustain for more than 2,000 years? Because eventually the late Harappans end somewhere around 3,500 years or something like that. Now, there are many indications. One of the major things which is coming very prominently is that, when the monsoon was good, they were basically growing, water-intensive crops like large grain cereals, wheat, barley, probably rice also. And when the monsoon started becoming weaker, they started growing, they switched over the crop pattern. They started growing what we call the drought resistant small grain cereal or millet. Even today, you go to the Western India where the rainfall deficit is there, millet is one of their main food source. So they basically, what we call, they did, they switched over the crop pattern for sustaining these things. Very interesting, although that almost 2000 years, rainfall is coming down. They are switching over their crop patterns. They are not dying. They are not leaving their settlements. And that actually gives us a great deal of, motivation that today the climate change is so serious that a 200-year-old modern civilization, human civilization, as Stephen Hawking says, that is going to be extinct in another 300, 400 years. But here is a striking case that the Indus Valley people could survive against the onslaught of what you call the decreasing monsoon for almost 2000 years by doing this kind of ingenious thing, that changing crop pattern. Today, if you go to any place in India, changing crop pattern is extremely difficult. You cannot ask the farmers to change the crop pattern. Vidarbha region, for example, they grow huge amount of sugar canes, which is water intensive. Vidarbha is a drought prone area. They want to stop sugar cane and they want to produce something which requires less water, but the farmers are not ready, government is not ready, the sugar lobby is doing. Now, that the Harappans could do it, it actually means that probably the societies were much more participatory. Okay? They were not fighting like modern civilized mankind. We have all good science, all good technology, but we have weak Ukraine, we have this, we have that, and we keep on fighting, we have politics, okay? And it never brings us to a convergence, okay? We can never agree for anything. But this is a very classic case that where over 2000 years, they survived by doing this thing. Not only this thing, they adopted very advanced kind of technologies, which I'll be showing few slides. So although that the Daily Mail London was very euphoria, with a great euphoria, they brought that Indus Valley civilization may predate Egypt's pharaohs. I don't personally think that is a very far-fetched as the journalistic, what you call over-exaggeration, I would say, okay? But notwithstanding that, one more question had been always bothering me is that for this 2000 years, okay, they survived, but why did they suddenly disappear? Now, for this, Hirana could not give us the answer because we didn't have the samples well into that because it had only mature Harappan and did not have the late Harappans. And after that, the Indus Valley civilization dies out. So we went to a place in deep run of Kutch. It's the greater run of Kutch, the place called Dholavira, which is India's one and only one exposed Indus Valley civilization city, which you can go as a tourist and see. Okay? And if you look at Dholavira, again, Dholavira is somewhere there, as you can see, in the northern run of Kutch, almost in the southern fringe of the Thar Desert. The white dotted lines are the rainfall isohyets, 500 millimeter rainfall annually, 400 to even less than 200 millimeter rainfall, almost arid, hyper-arid. As you can see from the landscape, no rainfall occurs. Okay? And within this run, you have these kind of beds, the rocky beds. Okay? And these Dholavira, they built 5,500 years back on one of these rocky islands called the Khadir Island. Okay? Very interesting. Why did they go and how did they survive for 2000 years? So we went to Dholavira. This is, for example, I will just quickly go through some of the pictures of Dholavira. This is the fortification wall. That means that any ancient settlements, the first thing they will do, they will make a defense structure, almost like the fort, okay, as you see in Rajasthan. So they will make a defense structure. This Dholavira was originally excavated in 1968 by J.P. Joshi, and later on it was taken over by Dr. R.S. Bist, who is still very active at 80 plus. And therefore, I had no hesitation to talk to him because he is the discoverer of Dholavira, and then started our collaborations. Okay, so this is a Google map of how you look at the Dholavira from the top. It has two rivers, right hand side one river, left hand side one river, and this is the mountain top on which they had built the city. The city had a castle. Castle means probably the most influential people is the right? They had a middle town, okay, where little lower hierarchy people probably were staying, and lower town, still lower hierarchy. So probably there were, you know, what you call, different kinds of activities were going on in these. And this kind of structure you find in almost all the Indus Valley civilizations, whether you go to the Harappa, whether you go to the Mohenjo-daro and things like that. On top of it, what you find in eastern side and as well as the southern side, inside, you see they built huge reservoirs. Why these reservoirs? These reservoirs are not ordinary reservoirs. These reservoirs are big, but these reservoirs are also connected to each other. Okay, that means if one reservoir is full, it will be immediately water will go to the next reservoir and then to the next reservoir, meaning that they are very conscious about the water conservation. And that only tells you that probably water was a very scarce commodity even during that time when the monsoon was continuously. This is what the present day, you know, river bed at Dholavira looks like. There is no water at all. Its rainfall is virtually zero. And only when little bit rain takes place, you get some kind of debris flow, and that's about it. It dries up in 1 or 2 days. Okay. This is what you call the east-facing entry gate of the castle. Okay, this is the gate. You can see a pillar element. Probably there was a gate. Gate is gone. I don't know what kind of material they made the gate. But if you look at the look at the civil engineering of this pillar, you will be amazed actually. The arcs are perfect. Okay, perfect arcs. Okay, on either side. And this is the time, remember, when iron was not discovered. This is the Bronze Age. And copper being a soft material, it could not have been used for polishing the rocks. So how did they polish? Okay. But as you go through Dholavira, you see a series of such interesting things. Arterial road. You have a very well-planned houses like our 2-bedroom, 3-bedroom, what you see in today's cities. They had dug wells, they have water tanks, they have step wells, and they had extensive drainage systems to the extent that they even had manholes. What does it mean? It means a very sophisticated water management system in Dholavira at a place which is inhospitable today. Okay. And finally, the largest reservoir, East Reservoir, which I was talking, you can see the steps, and these reservoirs they were using for conserving the water. Large number of pots and potsherds have been discovered from the Dholavira. Okay, variety of ornamental beads made up of variety of stones, a very precise weight system. Okay, the seals, all telltale features of kind of mimicking the modern kind of approach the human being has. You have shell bangles, okay, made up of conch. Gone today from rest part of India, only in Bengal and Bihar, women wear these shell bangles, okay. But interestingly, Indus Valley civilization side, you will see a plenty. There are factories where they were producing these shell bangles. Neither in Rajasthan or Gujarat women wear the shell bangles. I don't know how it got concentrated in eastern part of India. Bronze Age metals, starting from copper crucibles to fish hooks to spearheads, even the gold ornaments, silver coins, and what they did, because these copper ores have various kinds of trace elements like lead, they studied the lead isotopes. Okay, and these lead isotopes can tell you from where the copper ores were brought, and it looks that they were brought from far-off places of Gujarat itself, as well as Haryana, Rajasthan, or even Oman. Okay, Oman is the country where you have a lot of copper deposits are there. Okay, so you know there must have been very concerted effort of bringing these ores, smelting these ores, and making this kind of materials. Okay, and of course the most fascinating thing is the mankind's oldest signboard made in mineral gypsum. Okay, gypsum is a very soft mineral. If you keep it for a long time, it gets decomposed. Okay, somehow it survived. And of course, you have burial mounds where after the death they used to bury. And along with the burial mounds, they also used to give a lot of offerings, after death offerings. And large number of such cemeteries have been found in Dholavira. Okay. Now, question again is that in the run, white run we call, why they built this city in the remote Deccan. So a team of scientists from Deccan College, Physical Research Laboratory, Kach University, and IIT Kharagpur went and did very extensive work, part of which is published, part is still being published. This is the composite picture of what we call a Dhola Vida. This is one trench, this is another trench, this is another trench. Trench means you dig continuously and get the materials vertically, almost the same way we do in geology, and we start dating the materials. I will summarize. The settlement at Dholavira started around 5,500 years before present. Rapidly, they started expanding. The city was expanded. Okay, they made lower town, middle town, all these. They made reservoirs. Came somewhere around 4,300 years. Suddenly, the city, the expansion stopped. Expansion stopped. City was not being able. They were not being able to maintain the city, and eventually, somewhere around 4,200 years, the entire city collapses. Collapses and gone. They desert. They desert the city. You see a occupational, depositional gap there, okay, which we call in geology hiatus. And then again they come back somewhere around 3,800 years or so. But when they come back, those people are very, very primitive. They had no sophistication of these people who are living before. Okay, so this was a very startling thing, and we wanted to probe this. Now this one, as you see, this dating, what I showed here, is basically the Archaeological Survey of India had actually applied to UNESCO, for heritage site. Okay, and as you know that the UNESCO assess whether a particular place will be heritage site can be declared or not. So this chronology, I think, helped a lot. And in 44th session of the UNESCO World Heritage on 27th July, the Dholavira was given a status of World Heritage Site. Okay, till date, as you can see, the dot, 1154 such sites are actually there. So what did we do? At different levels, we found out these shells. Okay, seasonality I mentioned. So we started analyzing isotopes and their seasonality reconstruction. Where do present day these shells live? They live like this. You go to any mangrove, you go to the Sundarban Delta, you go to the mangrove regions of the Western India, you will be finding they are growing today. In Kutch, they were not there today, because Kutch is a desert. So the first thing, conclusion, the occurrence of this means the water was there, some kind of mangrove system was there, and that is how these people were collecting this mainly as basically the food source. Okay, many places, for example, even today we eat from the supermarket mussels. So these people also use, even today the villagers use these snakes. So these people were using them as a food source, and as you take the archaeological materials, they come out from the materials, and then we start studying the stuff. When we study these, few important things we find out. One is that the mangroves were there, okay, seasonality was there, and the monsoon was very prolific, okay. And as you can see here, that this mollusk, this is also a mollusk, they grow like this, okay. As they grow up, they grow like this, and as they are growing, these environmental isotopes registers in them the climatic parameters. So it's like a fast camera, okay. In the shell, there is a fast camera, and you are trying to find out the seasonality. The most interesting thing what we found out, that okay, there were mangroves, there were freshwaters, probably some rivers were there in the run of Kutch, and these water had substantial component of glacial meltwater. Now, where the hell in run of Kutch glacial meltwater will come? Okay, because it is so far up from the glaciers. We kind of reconstruct a picture like this in run of Kutch, somewhere in the early Harappan to mature Harappan time, okay, where people were basically collecting these materials, they were eating, and then they are throwing, which becomes part of the archaeological remains. But most important thing is that this river water near the Dholavira had substantial glacial water. Okay, we were scratching our head. Okay, it was good that during this good monsoon period, as the this artists to depict that they had a good agriculture, they had a beautiful market and things like that. But then came a massive drought. You remember that I said that around 4,200 years that city collapsed. And monsoon became not only weak, there was a mega drought over 200 to 300 years, around 4,000 years. Therefore, probably there was a resource crunch, water reservoirs were abundant, and eventually Dholavirans were or the Indus Valley people were very resilient over 2,000 years, could not sustain this major drought that is spread over 100 to 200 years. Now, two questions have to be answered. As I said, that what kind of river system it was. Okay. The most probable candidate is some distributary of the river Indus that debouched into the run of Kutch. Was there any river? You read some of the, you get in the, College Street or many places this book, Al-Biruni's, Indian traveler. You will see Al-Biruni, when he was moving through Gujarat and Kutch, he mentions that there were rivers in Kutch. But today there is no river. But when the Indian Space Research Organization people, they started studying the satellite imageries, this is the Indus River. The black colors are basically the riverine paleo channels. Okay, this is the Indus, and this is what the river channels around it. This is basically the hot desert. This Jaisalmer is here. This is Indira Gandhi Canal. So they named, of course, Paleo Saraswati. I do not know whether it's a Paleo Saraswati or not, but apparently there was a riverine course. Okay, these riverine course was directly coming into the run of Kutch. If that is not convincing enough, let us look at a 1746 British surveyor map of Mughal period. Okay, this was a British surveyor, a geographer, H. Moll, who was entrusted, okay, by the Mughals for making a map of India, okay, or India and Pakistan. You see, this is the Indus River. And look at this parallel to the Indus River, there is another river course. Okay. What is this river course? This river course today almost is dead. This is the Nara River. Okay, like we have a Narmada Canal, Pakistan has given a bund on Nara River, therefore, and they have made a Nara Canal project. The river does not flow anymore, it is completely gone. Probably this Nara River was carrying the water into the run of Kutch, and around which the mangroves were basically developing in this town. Okay, and glacial water? Yes, glacial water because it is a distributary of Indus River. If you go to the today's Indus River and collect the water, you will see that majority of the water is actually derived from the glacial meltwater, even up to its lower reaches. It's completely different from Ganges. Ganges also gets meltwater, but only in the upper reaches. Because in the lower reaches, it gets a lot of water from monsoon sources. So it loses its glacial character. But Indus never loses its glacial character, even just before reaching the Arabian Sea. Okay, it is possible that this Nara was very active, or the distributaries connected to the Indus was very active, and therefore those were the places where the people were collecting this kind of stuff. Second is, of course, it looks like an aridity. Was there a major aridity? After 2018, the geologists came and declared a new age in the geological time scale, which they gave Meghalayan age. Okay, a new phase in the history of the earth. Okay, and interestingly, the Meghalayan age nomenclature comes from studying a cave carbonate from northeast India, the Meghalayan cave, and it looks like that it is not only in India, it is a global phenomena that around 4,000 years to 4,200 years, about 200 years, there was a massive drought all across the globe. Certainly in the tropics and the subtropics, probably in the high latitude, they started getting this drought evidence even in the European continent. Interestingly, this 4,000 to 4,200 years, not only this Indus Valley civilization disappeared. No. If you look very closely, this disappeared, this disappeared, this disappeared. Okay? Till that, this kind of studies have not been carried out in Yangtze River, Mesopotamian or Egyptian. I'm sure they must be getting the, but let me just show you the time configuration of the Indian Indus Valley civilization sites within India. Okay. For example, Kalibangan in Rajasthan, Rakigori, for which Dr. Sinde is going to talk, and this is your Dholavira. You see, this is a violin diagram, basically a frequency kind of diagram. It starts somewhere, as you see, around 5,300, 5,500 years. This is the mature Harappan time when the cities were built, okay, and expansion took place. and come around 4,200, 4,100, Meghalaya stage, they all zoom, they are gone. Okay, they're gone. All the cities within India, they basically collapse. And simultaneously, not only the Indian sites of Indus Valley civilization, all the major old world civilization also collapse almost nearly at the same time. Why? The reason is very simple. Already, we had a decreasing monsoon. Explainable in terms of climate modeling as a solar insolation driven thing. Now, today, the understanding is that these decreasing monsoon, as much as it was decreasing the monsoon over India, Africa also has a monsoon. You must be knowing, Africa also has a monsoon. Okay, so this monsoon system was very strong in Africa also, but as much as it was going, it was becoming weaker in India, it was also becoming weaker in the African section. And then the Sahara, which was a green Sahara one day, suddenly crossed the threshold and became a Sahara Desert. Okay, so they called it is basically end of green Sahara. And how do they do it? They do it essentially by general circulation modeling. The climatologists do modeling for today's monsoon. They also started doing modeling for the past monsoon. Okay, and the reason they talk about this mega drought in mainland Southeast Asia is because the green Sahara suddenly collapsed, because climate is changing not gradually. Climate has a threshold, and it will flip over if the threshold is crossed. And this is what is the modern day IPCC is also warning us, that we might think that the climate change is gradual. Okay, Baba, temperature is rising, but you never know when this major flipping will take place. The prediction is that by 2030 to 2040, the tropical biosphere will collapse. If the tropical biosphere, especially in the ocean, collapses, the entire food chain gets haywire. Okay, so the kind of evidence which we get from the past has enormous bearing what can happen in future also. As you can see, the IPCC projection shows that the drought and crop failures are continuously increasing. Okay, you are experiencing now the South Bengal has got less than 30 to 40% rainfall than it is today. Not only in South Bengal, in the UP, Bihar, everywhere there is a deficit rainfall. IPCC also predicts that by end of the century, the temperature of the planet will increase if the business as usual CO2 is there, something like 5 degrees centigrade. It's enormous. If your surface air temperature is 5 degrees centigrade higher, it could cause catastrophe. Okay, if we have today hottest day in 20 years one, we will have hottest day probably in every 1 year or 2 years, and not one, even two. Okay, it depends on how we control what we call the CO2, or if we can at all control the CO2 emissions or things like that. So in a way, Dholavira presents a classic case for understanding how climate change can increase future drought risk as predicted by the IPCC group. Now, question is, of course, where the Dholavirans went. So collapsed, but the people who are there, people who are living, where did the people go? Okay. Now, if you look at the settlement pattern, this is the early part, all the red dots. So many sites have been discovered. Were there. Good monsoon, very nice agriculture. So people are building cities and the suburban areas and things like that. Come, in the what you call late Harappan, when the monsoon became weaker, you see majority of the sites are abandoned, and they started moving in the eastern side. Okay, they started moving in the eastern side. Okay, why they were moving in the eastern side? Because the monsoon over a century time scale, monsoon slowly retreats. Even today, for example, as much as monsoon front moves from south to north, it also retreats. Okay, so that is why we get monsoon till, for example, even in the beginning of October. Okay, which we call the return monsoon. The same thing happened over large scale also. The intertropical convergence zone, which drives the monsoon, okay, it slowly was retreating. So when the western part was unlivable, the eastern part was still livable. So probably they were migrating towards the eastern side. And, we indeed found in the deep run of Kutch, you can see in the desert, sand dunes, you can see the settlements. And the settlements age somewhere around 3,200 years, 3,300 years, and this is the time when advent of iron working comes. These are the site very close to Pakistan border. One cannot work there without the help of Indian Army. Okay, very inhospitable place. But you can see they had built up small settlement. Okay, all these settlements, what we found, have iron nuggets, iron materials. So after the collapse of the Bronze Age, the ushering of the Iron Age is there. So in a way, one can say that it did not really collapse. Basically, following the Indus Valley Civilization collapse, there was a massive migration from the western side to the eastern side. Okay, so again, journalists in euphoria, they started telling that Gujarat Harappans were the first climate refugees, and probably they indicate kind of warning which can happen in our case. Can I run that movie, please? In a way, this is dramatized, but not much dramatized. I mean, some science is there, and of course, rest of the things are basically the typical volume. Just click on it. This is from the very famous movie Mohenjo-daro. Okay, the very last scene of Mohenjo-daro, which you have seen.
ये जल स्वच्छ है भवन
इस नदी का नाम क्या होगा सर?
गंगा
Okay, so it's very dramatized, of course, no doubt about it. But certainly the migration indeed took place. And if you look at the early Iron Age settlements, they are all along the Ganga Valley and northern India. Majority of the Iron Age settlements in Gujarat, the early Iron Age settlements are not there. Okay, there is a time gap somewhere from 3,000 years to 2,500 years. The earliest one found around 2,600, 2,700 kind of things. Okay, in Indian history, this period is actually known as a Dark Age. Dark Age means the period about which we do not know much. I think this is the period when massive migration was taking place in Indian subcontinent, within the Indian subcontinent. But outside the Indian subcontinent, I'm not expert of genetics, but I just quote one line from Professor Bhargis Narasimhan's paper in Science, The Formation of the Human Populations in South and Central Asia. We reveal a parallel series of events leading to the spread of steppe ancestry in South Asia, thereby documenting movements of people that were likely conduits for the spread of Indo-European language. Now, I must tell you, I must also caution you that this is a highly contentious issue. So I will not, because it's not my expertise domain, but the map they give, look at the timing somewhere around 3,300 years BCE, which is the kind of Korimsai where we got the Iron Age settlement, southern Thought Desert, is almost a similar time. So whether or not such a large-scale migration was taking place, I am not sure, but certainly within the subcontinent domain, there was a migration from the westwards. Okay, so that is certainly clear. And it tells you only one thing, that today's climate change, all the predictions what IPCC are making, it had already happened. Maybe man was not there, fossil fuel was not there, nature was cruel enough to drive the climate change. Okay, and those climate change records are there. Evolution of those human settlements are there in front of us. Whether we what we call learn from it or not, that is to us, and it is also to us whether these 200 years old modern civilization will survive for another 2000 years or not. If you believe Stephen Hawkins, he is a doomsdayer forecaster. He says unless mankind find another planet, habitable planet in the solar system, on Earth, human being is going to be extinct. The very famous statement of Carl Sagan that extinction is the rule and survival is an exception. Okay, so I would stop my talk here today. I just would like to give some thanks to my collaborators from ASI, Professor Beast, from PRL, Deccan College, Kach University, Calcutta University, and a host of undergraduate and graduate students of PRL. And we got a lot of funding from, especially from Infosys Foundation, DST, CSIR, and so on and so forth. And we had a host of institutes we have been collaborating. And I must tell you that this is such an inhospitable place. Without their help, I just could not have put my footprint there. Okay? So thank you very much for your patience.
Sarkar. Thank you, Professor Sarkar.
Yeah, yeah. Yes. Yeah. That's it. One of the things I mentioned is that the nature paper which I mentioned in the book, they try to do climate modeling. They change CO2, they will change sea surface temperature and all that. So what they found out by doing the modeling that probably the solar radiation suddenly was stopped. Okay? Then they started looking at the records of the Sahara climate, okay, of the local lakes and all. And those climate shows that there was an abrupt shift in climate. And when they matched their modeling study, they probably tell that that if you suddenly collapse, you have a low monsoon, your vegetation is decreasing. But climate does not, as per their modeling, the climate probably behaves like a switch that suddenly flips over, that there is no going back again. Okay? There is no going back. So the Green Sahara collapses. So what you do, you expose the bedrock. So you have a huge amount of dust. So the dust goes into the atmosphere as aerosol. So you cut off the solar radiation. The moment you cut off the solar radiation, this battery cell which drives the atmospheric circulation becomes weaker. This is one of the mechanisms. But till date, we do not know. This is the only paper which has come in date. We are working jointly with IIT Pune and JNU private modelers because the problem is that in India, very few people do fast climate modeling. Most people work on modern climate because they are interested in modern monsoon. Okay? So, but I think slowly it is developing. very important. But one thing IPCC, even based on the modern modeling, they have suggested that already there are a couple of papers in nature that show that don't think that the climate change is going to improve. This will be catastrophic change. Catastrophic change means, you see, for example, the melting of the Arctic ice sheet. Okay, we know for last 20 years, melt. Okay, about 30 to 40% already melted. Now what they're telling that don't think that it will be that spread. It will come a day when probably 70 or 80% will melt in very short time. So that is what the danger is actually, which common people of course will not understand, because the politicians don't understand. There's many politicians when
Okay.
Trump does not believe that. So what they're telling that it's not a solar event. The solar radiation was going down anyway because of the anatomical geometry. So, which as was telling melancholic cycle. So you had a monsoon decline, as I showed, right from the, when the Harappans were built, monsoon was going down. Otherwise, Olavida, when they built such a beautiful city, why so process about that? Why this is so sudden? Because the climate, entire system probably switch over, flips, suddenly flips, it collapses. What is
civilization close to Ganga. So,
civilization? I have told you that we have a specific extent already. India, Pakistan, and probably part of Afghanistan. There are a lot of claims, but I don't think that that is found. However, the danger is there. I really do not know why so, but basically, this civilization grew along the river Indus. Okay. And the simultaneous civilizations, let's say Mesopotamia, what they call the Fertile Crescent. Okay. So these are the places they had actually developed. Around the Ganga, actually there are no archaeological evidence to show that such old civilizations are there. The city is as old as 4,500, 5,000 years. City is the Ganga plain. I don't think that can be. These are some questions which is very difficult for me to answer. I do not know, because archaeology is a science.
Okay.
That we don't.
okay, so yes. Thank you. Thank you once again for very nice talk. Right? So, something is a criminal that is former professor, vice chancellor of the Deccan College. That research is the word we must department about Professor Singh. Start as how the cultural, personal, medical complex. And then was the Czech professor, the National Institute of Advanced Studies, director of the prestigious research project, the largest number site of African currently processing based Hyderabad, as a department center for cellular and molecular biology. Sustainable complex Dr. Mr. Calculator from University of Pune. It is both the professor the National Museum and the University of Cambridge. While Professor Sinde has been a pioneer in archaeological research since last 40 years, specializing in the Proto history of South Asia, Indian history, as well as Greek archaeology. He has completed 16 major research projects collaborating with scholars and students from around the world. He has also created vast number of excavations around the country, from Harappan sites in Gujarat, Haryana, Archaeological sites in Andhra Pradesh, the Deccan, history, archaeological sites, Pakistan, and more. He established the Society of South Asian Archaeology, served as editor-in-chief of Ancient History, Research Journal. Then, Professor Sinde was lectured Genesis and authors of the Indian knowledge system, same research and practical. So,
So thank you very much, first time thank for guidance, for inviting me here in direct from this and Vaishali and everybody. And secondly, I would like to mention that perhaps it's a good scientific institute and the online sector subject is becoming so popular in the country. And naturally, one of the important researches that happen. And people are getting now quite good understanding about various aspects of on behalf of the on my behalf I wish everyone the Azadika Amrut Mahotsav. I join all of you for this. Now today, in fact, what I am going to speak today is the subject of very interesting discipline. We have been talking about the life of Harappans, and we know the little history of Harappans, how they lived, what was their culture. But we are not really understood, or we are not trying to convey the world what are the contributions made by Harappans to this society technology. And let me tell you that on the basic science technology that in India around 7,000 BC. And the gradual growth happening, we have a lot of archaeological data. And the gradual growth, and maybe by the middle of the third level BC, maybe around 3,500 BC, all the basic technologies were perfected, and we have followed here today the same pattern, without much change. So when the Britishers came here, or rather before the coming of the Britishers, India was doing very well. GDP of India was something like 35, 36%. And that is mainly because of the very robust basic knowledge and science we had. And on the basis of that, we had made tremendous progress. And Britishers realized that if this particular system continues in the country, perhaps it would be very difficult for them. And therefore, they systematically demolish the, uh, our knowledge system. And I'm really happy that today the government has realized the importance of this knowledge system. And they are now, including the syllabus, the knowledge system. So therefore, I thought that I should talk about this very important subject in front of the scientific community here, because everybody should know, where are the roots of our scientific temper and how we have progressed over the year. That is very important, and we need to understand that. Secondly, we have been discussing about the Harappan Civilization. I don't call it as the Indus Valley Civilization because that is the term used by mostly the Pakistani archaeologists and the European archaeologists. But in archaeology, of course, we follow the basic norms. And the culture is named after a site where it's identified. So it was identified at the site of Harappa, therefore it is called the Harappan culture and the Harappan civilization. The two words we are using. The total time span of the Harappan culture is from 6,000 BC to 1300 BC. That is the total span of the Harappan culture. But there is one phase of the Harappan culture, the most prosperous, and that is from 2600 to 500 BC, 1000 or 1900 BC, during which we see the development of urbanization. So this particular phase is called the Harappan Civilization phase. Now, what is the significance of the discovery? It is said that this was the most important archaeological discovery of the 20th century. Not because we discovered one more civilization in Asia apart from Egyptian and Mesopotamian. But before the discovery of the Harappan civilization, Harappan culture, it was always thought by most of the historians that there is a big gap in the history of the country. In fact, if you read the book by Vincent Smith in the beginning of the 20th century, he says that India developed from Stone Age to the Stupa period or the Buddhist period. And most of the developments happened much later in the country. But with the discovery of the Harappan culture, the antiquity of the second life was pushed back by almost 3,500 years. And now, in fact, we boast of a continuous history of almost 2 billion years. The earliest stone tool discovered in the Indian subcontinent that dated to around 20 lakhs, 2 billion. So from 2 billion to the present, we have a continuous history, and that is the very important part of the our history. Therefore, we feel connected. Right? But whenever we excavate inside, generally, stay there for a couple of months, and we study the people also, their culture also. So whenever we have time, in fact, in Archaeology, whenever I used to go to a village, I used to get a feeling that I'm moving the Harappan village. So much similarity. And that indicates that we are really following our ancestors very vigorously. So that is one part of this particular. Secondly, the other important maybe political implication of this particular discovery that before the British has given information to the world that we have come to India because we want to civilize these people, we want to integrate these people. But when they discovered the Harappan civilization, the Bengalis have played a very, very important role in the excavation and the discovery of the Harappan civilization. The Colonel Banerjee particularly was the main architect of the excavation site Mohenjo-daro. So when this particular culture was discovered, for 4 years now they were not really able to understand what are the remains or how old the remains are. And on 20th September 1924, the announcement of the discovery of the Harappan civilization was made. Now, there was once this civilization was exposed at sites like Harappa and Mohenjo-daro, then the Britishers had a major problem because then how to justify the good British rule over India. And they said that, okay, because Britain also did not have such an advanced civilization, ancient civilization there. They said that, okay, you have the remains. We know that it was a very advanced civilization. But the people who made the civilization, they were not Indians. They came from outside. Mostly now they pointed towards west. And they said that people from the west, they came here and they established this particular civilization. So in a way, they wanted to give impression that Indians are not capable. But later, of course, now as we have done tremendous progress, maybe I'll be talking about that at some stage. But let me give you the little background. What is the beginning of the maybe cultures in Subcontinent? And there are some sites like this is a tool, in fact, which is the earliest tool stone to be found in the Indian subcontinent. And this is dated to 2 million years. So from 2 million, in fact, to the present, we have, continuous history. And it is believed that the person who fashioned this tool, the man, in fact, who fashioned this tool, he was the best technician because he did this for his requirement. And then, of course, we have, this continuous Stone Age sequence. Okay. Okay, so we do have evidence about the gradual growth in technology in the Stone Age period. And the earliest stone tools were very heavy and rather heavy to tools. And slowly, of course, now there is a gradual change in the technology. So we have some evidence in this respect. Okay. Okay, so these are the tools found in fact in the middle level and the upper level. So we do see some kind of gradual growth in this stone tool technology also from the beginning of maybe from 2 million years in almost 10,000 years. So this is how the early stage is. But most of the developments happen in fact after the discovery uh, or the of the early farming settlements in the Indian subcontinent. Now, in Indian subcontinent, people started settling down at one place around 7,000 BC. We have the earliest date on site of Mehergarh in this respect. And it is believed that because the monsoon became quite active, people it was becoming favorable for the agriculture and various other activities. Because of that, the settled life began back in the subcontinent. And yeah, and the evidence that we have from number of sites clearly indicate that maybe the beginning is around 7,000 BC, and that is called the early food production era or the formative stage. And then, of course, now we find the developments from here to the next level. And this is a complete sequence of the from beginning of the settler life in the state of the Harappan culture. Most of the early developments happen in fact in the northwest part of the Indian subcontinent and not in the Gangetic plain. Somebody asked this question because the research that is done by Professor Singh from Lucknow University, he has clearly indicated that the evidence that maybe when the early cultures were developed in the northwest part of the Indian subcontinent, the most of the part of the Gangetic dwarf was marshy land and a lot of grass was grown there, and therefore the early settlements have not really happened in that particular part. And on the other hand, this region is very ideal because now we have a lot of natural resources available here, and the two river systems, the Indus River and the Saraswati, which is also known as Ganga River Basin. Now these were the two important rivers, in fact, which facilitate the agricultural activities. But this is the site of the area where the site of Mehergarh was discovered and excavated. You can see these are the mountain ranges, around the very fertile basin, and these mountain ranges in fact have most of the natural resources available for the early modern communities. Because of that, development happening. What you are seeing here is the archaeological mound. This is the mound where you find most of the vintage. And the site of Mehergarh, in fact, has a continuous sequence from 7,000 BC up to 2000 BC. And therefore, there is a very strong or very thick formation of the debris here. So that you can see here. And in this debris, the excavator could identify the gradual growth of the culture from 7,000 BC to the beginning of the Harappan culture and the Harappan civilization. So we have very strong archaeological evidence. The people in fact began their lifestyle very modestly. They built these type of structures, very small and big structures of mud. And then of course now there's a gradual development happening in that. These are the people who introduced agriculture. Wheat and barley was the crop it's, grown by these people. And also they, along with the exploitation of the wild animals, they also exploited, or they also started domesticating of some of the animals, particularly sheep and goats, and also cattle was the animal which was domesticated by them. And we have the evidence for that. So at the site of Mehergarh, now this is the earliest evidence of the ceremonial burial within the habitation. And right from the beginning, people believed in that in life of a day. Because along with the dead body, we do see some, lot of burial goods along with this. So in this case, these are some of the ornaments which are found along with the dead body. And also you can see the container. This is not pottery, but it is a basket which is plastered with clay. So these containers and the jewelry also was a part of the burial goods. So that means people have believed in fact in life of the faith, and they have found this particular belief has continued from Harappans to modern times. And also these are the people who began to develop the basic technology for manufacturing of these type of ornaments. So we do have evidence of that. We do have evidence about the manufacturing, about the introduction of basic technology and sciences in this particular stage. And they gradually, in fact, they develop these technologies in different parts of the uh, northwest part of the Indian subcontinent. But also important that they also started importing raw materials from very long distance. So right from the beginning of satellite, they developed contact with different regions. For example, at the site of Berger, we do find these type of pearls, and these pearls have come. Scientifically, it is proved that these pearls have come from Oman region. So they had contact with Oman region, and these are the kind of shape, Tattoo Pyram, which is coming from the Karachi coast. And Karachi is roughly 900 kilometers away from Mehergarh. So that means, right from the beginning of the second life, the people began to develop contact with the far off places. And that is reflected not only in the archaeological data, but also in the genetic data that we have studied. So I'm going to show that also. Also, they started maybe at some stage, maybe this is the earliest spot we found in the Indian subcontinent, dated to around 6500 BC. The early pottery is handmade and proved, and gradually now one can see the development in the ceramic technology in this part. Okay, now I'll just show you the Harappan region, right, where most of the developments happen, or what I can say that most of the basic technologies and sciences were perfected by the Harappans in this particular region. In fact, a very vast region was occupied by the Harappans. Nearly 2.5 million square kilometer area was occupied by the Harappans. And we do find, we have discovered number of sites in this region. So far, we have discovered 2,000 Harappan sites, out of which maybe 1,500 sites are on Indian side, and the remaining are in Pakistan. And we have studied more than 100 Harappan sites, and these are some of the important sites that have been discovered, that have been, uh, you know, excavated in the Saraswati Basin, and also you can see the location of some of the important sites like Harappa, Mohenjo-daro, Ratnagiri, etc. in this map. One misunderstanding that most of the Harappan sites are maybe cities or towns. That is not true. There are only out of 2,000 sites, there are only 5 Harappan cities. And these are the cities that you can see here. Now, before the large scale excavation that we started at the site of Ratnagiri, it was always believed that Mohenjo-daro was the largest Harappan settlement, Harappan city. And then, of course, followed by Harappa, and Ratnagiri was the third largest. But after we started the work, we have calculated the area of the site very systematically. And now the site is found to be spread over an area of roughly 550 hectares, almost double the size of Mohenjo-daro, which was supposed to be the biggest Harappan city. So we have, in fact, the data from number of sites, and when we talk about the maybe basic science, or I always think that that the knowledge system that was introduced by Harappans, that is the typical Indian knowledge system. And I'm going to show you what is the evidence in fact in this respect. So these are the two major river basins. One, of course, is the Indus River, and the other one, of course, is the Saraswati River or the Ganga River. Now, out of 1,500 sites that are found in Indian subcontinent, nearly 1,000 sites are located in the Saraswati Basin. So there's a very high concentration of the Harappan sites in the Saraswati Basin. And compared to that, there are few sites in fact in the Indus Basin. The reason for having more sites in fact in the Saraswati Basin is that Saraswati has a lot of water, and the river is very safe. The Indus River is very ferocious, and even today you find very few settlements located along the main river Indus. But that is not the case in fact in the case of Saraswati. So we have large number of settlements in this particular. So these now the Harappans they did have contact with number of cultures that flourished in the West. They had contact with this part what is known as Magan, or the coast of Oman and Bahrain, that's the part. Then they also had contact with Persian Gulf, with Mesopotamia, and also with Egyptian civilization. So we do have evidence in fact in this respect, archaeological evidence particularly, and that evidence is very, very strong. So I'm just going to show you that how the this how this growth has happened. The excursion that we carried out at the site of Rakigadi. Now here in fact Rakigadi has perhaps the thickest habitation deposit. You can see here in fact almost 24-meter deposit, in which we have found the remains of the early Harappan phase, about which Dr. Sarkar has mentioned, and also the mature Harappan or the Harappan civilization phase. And for the first time now we have understood how the growth or the transformation has happened from early Harappan to the mature Harappan phase. And that evidence in fact is reflected in fact in the structures, in their pottery and other material culture. And particularly in case of the structures, uh, uh, particularly this particular site was also mentioned by Dr. Sarkar, the site of Mirana. And it is for the first time that one could get idea about the gradual growth of the structural activities of Harappans at this particular site. So Harappans lived here in very small circular structures. What you are seeing in fact here, these are some of the small, they are known as the peat dwellings. And they are found in fact in clusters. So these are the peat dwellings which were occupied by the Harappans, early Harappan people. And this is the kind of evidence we find in fact in the early Harappan level, that is the beginning of the 6th millennium BC. And then, of course, in the next stage, in the subsequent, different stages, we have the evidence. So in the next stage, one can see that, that the structures now, they are made over the ground, but still, the circular structures continue. In the third stage, one can see proper growth of the structural activities. So they are now building rectangular structures. They have used the typical Harappan bricks in the ratio of 1:2:3 or 1:2:4. And some features like, tandoor and domestic hearth, etc., they are found. So now in the third stage, we do find some development. And in the fourth stage, one can see the modicum of planning. This is the evidence from the site of Harmana, which I excavated before the site of Rakigadi. And here at this particular site, we have uncovered the part of the settlement, part of the city, which was occupied in the fourth stage. So this is the evidence from the fourth stage. And finally, we have the full-fledged town planning. So this is, this is the kind of evidence that we find. So certainly, that, the Harappan civilization was not suddenly introduced. There's a gradual growth happening in fact in the subcontinent, and we have strong evidence in this particular respect. I would like to mention in fact the very strong evidence from the site of Dholavira, which is one of the iconic sites in the country. Now, Dholavira has, you can see this is the only city which is divided into 3 parts. Harappa, Mohenjo-daro, they were divided into 2 parts. One is called Citadel and the other part is called Lower Town. But here, this city was divided into 3 parts. And what is interesting here, in fact, one can learn a lot, in fact, from the development town from here. They had to develop this particular city here. And they were aware that, this is an almost dry area. They knew that there is a dearth of water here. So before the establishment of the settlement, the Harappans studied the geography and geology of the site properly. And they intentionally located this city between two rivers. One is called Manhar, the other one is Mansar. And they created facilities here. One of the best evidence of water harvesting and water management comes from this particular site. But what you are seeing here, very massive, fortification wall. This fortification wall is almost 18 meters on top, and it broadens over the base. And even today, in fact, we have no clue as to why the Harappans have to build such a thick wall. But recently, in fact, with the help of Indian Institute of Oceanography in Goa, we have carried out some research in this respect. And just close to the fortification wall, we have found a heap of sand. And that heap of sand was a one-time event, not maybe regularly deposited, not like that. But this has come at one time. And there's a strong possibility that the sea was close to the site that time. And there's a strong possibility that there was always a danger of tsunami. And to protect the settlement from tsunami, probably they have built such a thick wall. So that you can see here, a very thick wall here. And you can see a very, very well meticulous planning of the city. City had 4 gates on 4 sides. This is one of the main gates on the northern side. And you can also see the security arrangement made on the gate. So the entry was restricted. Yeah, one can see these are the flight of steps on the northern gate. One has to climb up the steps, turn to the right, and then turn into the city. And very elaborate security arrangement was made by the Harappans at this particular site. And you can see the town planning, right? Perfect north, south, and east, west running, main streets and structures on both sides. So this kind of evidence is not really found in Mesopotamia or even in Egypt. And it is believed that this particular aspect was given by the Harappans to the world. It is always believed that the Harappans have taught the world how to build very systematic, very well planned and hygienic cities. And this is one example, in fact, of the Harappan teaching. In fact. Also, you can see that when the site was discovered by J.P. Joshi from the Archaeological Sites of India, he never excavated the site, of course. And then, of course, RSP started the excavation in 1990. And before the excavation, they could see some of these polystone pillars, the component of pillars on the surface. And J.P. Joshi particularly was convinced that these are the polished stone pillar bases belonging to the Harappan culture. Before J.P. Joshi, number of scholars visited the site, but they saw the site from a long distance. And everybody thought that this is a medieval fort because it looks like a medieval fort. So J.P. Joshi was the first, by 1968, to go to the site. And he first made a statement that some of the polystone pillars that are found, they belong to the Harappans. And later, when RNPs carried out the excavation, he could actually find these pillars in situ in the structure. And on the basis of that, it was suggested by him that this particular art was introduced by the Harappans. We do find here polystone pillars, in fact, in the Mauryan period, and it was always believed that this particular concept has come from Persepolis in Iran. We have learned from the Iranians that was the earlier concept, but now we know that this is the earliest evidence of its kind. And here you can see these different maybe pillar bases. These are the pillar components which are found along in the excavation. So this is the Harappa's very, very important contribution. Secondly, also we always believe that the Harappans have carried out trade in small and luxury goods, but also they carried out trade in the building material. We do have some evidence of stones from Mohenjo-daro and also from Harappa, and those stones have been scientifically studied. The petrography of the stones has been studied, and it is revealed that most of the raw materials come from Dholavira region. So Dholavira, there is a very very close to the site, there's a stone quarry, and that quarry was exploited by the Harappans, not only for their needs, but for the maybe trade purpose also, and we have the strong evidence of that. And as I mentioned that, that there's so much continuity. Even today's settlements look exactly like Harappan settlements. So you can see the, you can compare the Harappan planning and the planning of the modern settlements. And this is one classical example of that. One very important contribution of the Harappans in the history of maybe technology all over the world is that Harappans introduced a very scientific construction method. Today that method is called English bond. But English people were not really aware about that in 14th century AD. But we have the earliest evidence of that in fact in the Harappan levels. So here in fact in the case of the brick wall, one line of the brick is placed horizontal and the next line vertical. That is how the construction is followed. And that method is called the English bond method. So Harappans have developed that. And we always believe that instead of calling this as English bond, we should call this as Harappan bond because they are the people who introduced. So this is, you can see, these are the remains at the site of Mohenjo-daro. And here you can see that clearly one line of the brick is horizontal, one line is vertical. And this is the modern construction we are still following, not only in India, but all over the world, this particular method is followed. So we have this, a very important evidence from the Harappan levels. We don't know whether the Harappans knew mathematics because we have no evidence about that, no textual evidence so far. We have the Harappan script, but we have not been able to decipher the script. But we have found these are the maybe measuring instruments found at some of the Harappan sites. So from this one can judge perhaps the Harappans knew mathematics. And these are the measuring instruments from different sites discovered. So this is a very, very important evidence that we have. Yeah, these are some of the more evidence of that from different sites. From 4 sites, we have this particular evidence. So most of the measuring scales were made of either ivory or wood or sometimes terracotta. Also, the Harappans were pioneer in the world, in fact, in building wells. This is the earliest evidence of its kind found anywhere, in fact, in the world. And you can see the type of the wells that the Harappans have built. In fact, when the excavation was carried out at Mohenjo-daro, they found almost a well in every household. So that's the kind of facilities Harappans created. So this is also considered to be one of the important contributions of the Harappans. This particular, bathroom, you'll mistake this certainly for modern bathroom. But this is the actual Harappan evidence bathroom from the Harappan site of Kalibanga. And now, in fact, around 2500 BC, the Harappans have introduced most of the basic facilities required within the structure, within houses. And this is one facility that was built by the Harappans. But what is interesting that your Harappans have made tiles. We always thought that the concept of tile has come from the West, but that is not true. In fact, this is the earliest evidence of its time. So these Harappans were so advanced, in fact, in their age. The other important facility, which is unique in fact for the Harappans or in the entire world, is a very meticulous civic amenities within settlement. So the Harappans, we have the evidence of the open drainage. This type of open drainage were attached to the bathrooms. Every household had bathroom and toilet. So this is the evidence of that of the bathroom drainage, and also they had the closed drainage system which was attached to the toilet. So that kind of evidence is also found. So this is again, we do not find this kind of evidence in Mesopotamia or even in Egypt. So Harappans are considered pioneer. So they have properly taught the world in this respect, and they have followed very simple method. The the drainage was going from the higher levels to lower levels. So they have followed this gradient pattern, and that is how they were able to keep the cities very clean. What we have, in fact, now we have the series of web structures, and you can see that each structure had a bathroom and toilet, and that was attached to the main drainage line. And this main drainage line was taken outside the city wall. In fact, now we have very strong evidence from the site of Harappa. You can see this is the opening of the main drainage line, which is outside the city wall. So the Harappans have made sure that there is no dirty water sprayed within the settlement. And because of that, the Harappans were so healthy. In fact, we excavated number of skeletal remains, and some of my Korean, colleagues, they are working on the pathology of the during the Harappan times. And at the end of the study, they were disappointed. They said that the Harappans were so healthy, not they find major diseases in fact prevalent during the Harappan times. And they were healthy because of maybe the system that they developed within the Harappan city. So this is a very, very important aspect of the Harappan town plan. As I mentioned that we are following the Harappan tradition. I always believe that the Harappans were the founders of the Indian culture and tradition. And but we rarely learn from them. Now this is a picture of one of the streets in Rakigadi, followed in fact more or less the Harappan pattern, but the drainage is open in fact in the street. So we are not really following the Harappans in true sense. For everyone, in fact, this is the evidence of public bath. This is what is written in fact in the textbook. But I feel that this is the earliest evidence of swimming pool, because most of the paraphernalia of swimming pool are found here. First, there are flight of steps. These flight of steps were not made to go down every day, but for the maintenance purpose. And secondly, one can see these are the blocks, but there are a number of rooms around. Even in today's swimming pool, we do have this concept. So I believe that perhaps that Harappans were pioneering in this respect, and they have introduced even this system, and they are the first in the world to do so. Okay, and the most important evidence that we have from the site of Lothal in Gujarat is the dockyard. You can see, this is the structure which is excavated by the Archaeological Sites of India. And this is considered to be the earliest dockyard anywhere in the world. And that is true because we do not have this kind of evidence anywhere in the contemporary society in the world. And therefore, we believe that the Harappans were the pioneer in this particular respect. So what they did, in fact, the Harappans were the first to develop maritime contact, maritime trade with Persian Gulf region, with Mesopotamia and Egypt. And literally they were plundering those people, because the trade was always surplus in favor of the Harappans. So they were getting a lot of wealth from them. And here, in fact, the philosophy of the Harappans is very, very important to understand. They have not used this particular wealth for constructing structures, maybe public architecture, which is of no use to common people. For example, in Egypt, we find a lot of pyramids, also a lot of temples. The Harappans have not done that, because the Harappans were very practical people. So they have used this wealth, this revenue, for developing very clean and hygienic cities for the common people. So that is the difference between Harappans and the contemporary population outside the Harappan region. So in order to facilitate the maritime trade, they developed this dockyard, and it was used as a port also. And also we have the earliest evidence of boat also from the Harappan levels. You can see that they had two kinds of boats. So boat building activity, again, was taught by the Harappans to the world, not by the Romans. So we have two types of ships. One is the wooden plank boat, and the other one is the grass boat. It's called the reed boat. And both these boats were used for deep sea going, because in this case you can see a house inside the boat, and also birds. So house is required because you'll be traveling for days. You need that house inside, and the birds are required to locate the land nearby. So this has been found in both, in fact, in both both these boards, and these boards are exactly the same boards are being used even today. This is a picture of it, and when I went to Mohenjo-daro, I could see that the modern people are using same kind of flat bottom boards even today. So there is so much continuity found in the northeast part of the subcontinent. And now I am going to discuss a very, very important knowledge that the Harappans have left behind. The best evidence of water harvesting and water management. Briefly, now Dr. Sarkar has mentioned about that, but I'm going to tell you in great detail because this is a very, very important, and this knowledge is even relevant even today. In fact, I gave a lecture to the Niti Aayog people, and I suggested that this knowledge can be put to use even today. And entire Kutch part or the desert part can be converted into green land, provided we adopt the Harappan knowledge system. So it is relevant even today. What the Harappans did, they intentionally located the city between two small rivers, Manar and Mansar, and then they put series of dams on this. We have the evidence, actual evidence of the dam on these rivers. So in the desert part now, whenever there is a occasional rainfall, maybe these rivers get flash floods. So the Harappans have diverted all the flash flood water inside the settlement by putting this type of check dams at regular intervals. And then, of course, inside the settlement, as I mentioned, that settlement was divided into three parts. In all the three parts, they have the underground water tanks for the maybe storage of the water. So that is a very, very important evidence. And because of that, the climate was not much different from today. Even that time also, this was a desert part. But Harappans had to develop this particular city because this is located on the very, very important trade route between Saurashtra and Sindh region. And they had to develop some series of settlements, and Dholavira was one of them. But by using this basic knowledge or basic technology, Harappans could overcome these difficulties at the site. So they knew that there is a lot of water, so they took proper precaution for that and developed this facility there. So again, for the check dams, they have used this, the gradient system, and then you can see whenever there is a rainfall, you get this type of this is how the the flash flood come there. And probably, this is just conjecture that probably this type of, barricade may have been, used by Harappans, and they diverted the water inside the settlement. But what they did, in fact, suppose, the water comes in, huge volume, there will be maybe, a danger to the settlement. So they had created what is known as the outlet for stormwater drainage system. That was system that was created. And today also, these type of systems are followed even today, when the dams are constructed. So this is a very, very important evidence that we find. We do not have this kind of evidence anywhere in the contemporary world. So the Harappans were the best civil engineers, and this is one of the examples of that. And these are some of the water tanks, underground water tanks, excavated by the Harappans. So the excavator has uncovered nearly, 9 to 10 different water tanks of different shapes, different sizes, and as was mentioned that there's a provision right now. The tanks can be filled one after the other, when there is a rainfall. So most of the tanks will have water. So this is very, very important. But what is interesting and what is intriguing here is that how the Harappans, who had no iron instruments with them, how they were able to excavate in a solid rock. And particularly this one, this is dug into solid rock, maybe almost 3 meters. So how they must have done that? They only had maybe copper or the bronze chisel at most, and they are not really effective for this particular purpose. But probably the one system that they have developed, which has continued even today, is that now if you want to excavate this type of maybe water tanks, maybe you try to remove the stone blocks, and to remove the stone blocks, now you make a wide and deep crack on the periphery, and then put wooden pegs in that and keep pouring water in that, so that the wooden plate starts swelling and they crack the stone. So that is how the stones must have been cracked. They must have removed these blocks, and by using maybe bronze chisels, they must have smoothed the sides and the bottom. And even today in Karnataka, in Gujarat, this system is followed by the local national structure. So this is a very, very important evidence we have from the Harappan levels. This is, of course, the biggest tank. But what is interesting in that biggest tank is a small well. And Gujarat is known for the step wells. But most of the step wells found in Gujarat, they were supposed to be from 6th, 7th century CE or AD. But this is again the earliest evidence of a step well in Gujarat. So maybe later people of the later culture, they may have maybe derived particular concept from the Harappans. So we have this evidence also from the Harappan levels. And you can see, the biggest well in the Harappan level. This is from the middle town. And you can see the drainage pattern also. Not drainage, but the water channels, inside the settlement. So here, suppose this well is very deep. Suppose the water from the tank is finished, exhausted. There will be always water impact with the deep wells. So they can draw water impact. There is a flat stone here, and there are a number of grooves on the flat stone. So they might have used some kind of maybe buckets, maybe of leather or some other material for drawing water, and that water may have been put in this slope here, and then through these water channels, the water can be transported to different tanks found in different levels. And you can see that Harappans have provided air ducts in this underground water channel system. And even today in Penang, this is the basic effect for prevention of blockage or also for the maintenance purpose. The air ducts are required. Even in the modern drainage system, it's a very integral part. And that system was introduced by the Harappans. And you can see, the height of one of the underground this water channel. So you can imagine right now how much volume of water was flowing. And because of the flow of water, the stones have eroded. So definitely, this was used for the, for water purpose. So that is quite clear. Also, Harappans, they did a lot of advancement in the agriculture activity also, agriculture technology. And at the site of Kalibanga, these type of plow marks were found, furrow marks. And there are two, furrow marks in two different directions. There are some furrow marks which are close to each other in one direction, and there are furrow marks, which are in different direction. And even today, the same system is followed. And in the furrow marks which are close to each other, today people grow the main crop like wheat and barley. And at the same time, in these furrow marks, they can grow secondary crop like maybe gram or maybe sarso in that. So that is the system, and there is a continuity from Harappans in modern times. Also, this is the model of the agriculture implement found at the site of Banauli, very close to Ratnagiri. So that also indicates that that we have not really modified or changed the basic agricultural tools from Harappans till today. The medium has changed. Harappans have used mostly maybe wooden tools, or sometimes the plow share must have been made of either bronze or copper. But today, of course, we are secured to iron or steel. That is the only difference. Otherwise, we do find continuity in that also. The beautiful pottery was produced, but this is from the middle level, from Harappan Civilization phase. And the pottery found in the Harappan Civilization phase is considered to be the classical pottery. But the pottery from the early level is, very crude and handmade. And one can see gradual growth in the technology, ceramic technology at number of sites. So these are the beautiful Harappan pottery. And you can see that some of the uh, pots are very, very high, maybe 6 feet high, 5 feet high, and how they must have fired this pottery perfectly. In fact, Harappans have used. Even today, we follow more or less same pattern. Yeah, you can see, even today, people are manufacturing, making these earthen vessels, and they're following the same pattern, not much different. If you put one Harappan pot and one modern pot side by side, it's very difficult to identify which one is modern and which one is ancient. There's so much continuity in that aspect also. And of course, now the potters are following the same Harappan technology for making pottery. Harappans also, use specially designed kilns for firing purpose. And in these particular kilns, Harappans were able to raise the temperature up to 1000 centigrade because the pot is perfectly fired between 750 to 1000 centigrade. And these are the kilns which are used by the Harappans for firing this pottery. So we have evidence from number of Harappan settlements. Then, of course, the Harappans also, developed basic craft in the, maybe in the form of either jewelry made of semi-precious stone. There is a lot of evidence in this respect. We have the evidence of the manufacturing of this at some sites like Bolavira, for example. We have beads in different stages of manufacture. Some are broken, some are complete. We also have, the tools which are used for maybe polishing purpose. This is the bead polisher, and these are some of the trees which are used for polishing purpose. So we have the evidence of the manufacturing activity at some of the Harappan site settlements. So this is the technology that was perfected by the Harappans. It started maybe around 7000 BC, but perfected by the Harappans around middle of the 3rd millennium BC. They also made, some, these are the beads made of semi-precious stone, particularly carnelian. And they also developed a technique by which, they could make some decoration on the outer surface. And Mark Canoyer, who discovered the site of Harappa, he tried to, do some experiment. What kind of maybe material the Harappans may have used for making these different patterns? They are called the H carnelian beads. And we do have a lot of evidence of these in Mesopotamia and Egypt. So a lot of these were manufactured only for the international market. Some of them were only for domestic market. And even today, in Khambat, there are some, bead manufacturers today, and they are using the same Harappan technology even today. These are some of the modern ones. Then, of course, Harappans, had knowledge about uh, copper technology. Perhaps they learned that. And two types of technologies were used by the Harappans. One is, of course, the simple, what is known as cold hammering technology. The sheets were, were fired. So this, this special technology was developed by the Harappans. And in the contemporary world, of course, they only had the knowledge about this. And a lot of people are following on today by using the same technology. Particularly some of the craftsmen in the Khambat region, they're manufacturing beads of semi-precious stone, and they are exporting all over the world, but they are doing roaring business in this. And these are some of the tools which were made by these Harappans by using the simple cold hammering technology. The seeds are, being beaten into desired shapes. So this was quite common. And the other technology they used was, of course, these are some of the ones which were made in the mold, in fact. They use this complex technology also. And even this bronze figure is found that is also made in the mold. So the Harappans had developed this very simple as well as complex technologies for metallurgy purpose. And we have at number of sites, we have extra number of sites, and we can see here, we have the evidence of the manufacturing of some of the copper artifacts. This at one of the sites in Gujarat, we have this number of furnaces. The copper was brought from outside, melted copper, and the melted one, of course, was reheated. And for reheating, these type of small furnaces were used. And you can see this, these are the working stones found in some of the structures. So this is the basic technology that the Harappans used. The Harappans also, for the early farmers in this part of the world, they also use cotton. The earliest use of the use of cotton goes back to 7000 BC at the site of Mehergarh. So we are pioneers in this particular respect also. Then also the dye was made by Harappans. This is the evidence from the site of Harappa. These are the circular platforms where the indigo plant was crushed and the this color was extracted from that. And probably now these type of structures, this was identified by Wheeler as the granary. But nowadays, now a lot of scholars believe that these are not granaries, but probably these are the places where the textile was manufactured. So we have, very important evidence in this respect. Even, we have the evidence of wool. This is actually evidence coming from Harappan labels. So wool fabric was made by Harappan, jute fabric was made by Harappan. They were pioneers in this particular respect. They were the earliest in the world in this particular respect. Also, we found the silk trade also. And the silk that was used by Harappans was the silk of the domesticated variety, not wild variety. And this is the earliest evidence of domesticated variety anywhere in the world. China is not the maybe pioneer country in this respect, but the Harappans were the pioneer in this respect. And we have a lot of evidence, a lot of experiment has been carried out, a lot of scientific study in this respect has been carried out. These type of small beads, tiny beads made of a paste or very soft stone that is found. And even today, of course, these type of beads are made. Maybe now they're using different material, but this type of beads are made for embroidery work purpose. So there is a continuity in this particular aspect also. The weight and measuring system, Harappans had developed that properly. And it is believed that the subsequent scientific measuring system was developed based on the Harappan system. Even they had made tremendous progress in the metallurgy also. The silver and gold was used for making some jewelry, and they had developed technology for making these ornaments. You can see one of the sites in Saurashtra where the shell bangles were made on large scale. You can see this is a workshop. This is the raw material. These are some of the maybe broken shell bangles. Also raw material here, and you can see the amount of shell bangles. So in Saurashtra particularly, they had established some industrial sectors where the particular material was manufactured on large scale because there was a greater demand for the Harappan material in West Asia. Again, this earliest evidence of tandoor. Tandoor chicken is the contribution of the Harappans. We have the evidence of tandoor at number of Harappan sites, and also roasted chicken bones have been recovered from some of the Harappan sites. So it is considered that the Harappans are the pioneers in this particular respect. And we have the evidence. You can see here, if I one of the tandoors, you can see the lumps of clay. And you know that today, the lumps of clay is used for sticking roti. So that is kind of evidence we have. Then, as I mentioned, chicken tandoor is the contribution of the Harappans. Also, at the site of Parmana, in the burials, we extract some pots in the burials, and those pots were subjected to scientific, residue analysis. And in the residue analysis, we found the ingredients of curry, Indian curry, So you find the evidence of ginger, haldi, brinjal in one of the pots. So the Indian curry, the antiquity of Indian curry goes back to the Harappan time. So this is very much, Indian dish. Yeah, the burial, you can see that, these are some of the pots which were subjected to these scientific studies. And we always thought that the food processing has come from the West. But again, you can see that Harappans were the first to process the milk product. And they produce, this type of, the cheese and also, you know, number of dairy products they made, cheese and paneer. And initially, we had no idea as to what is the use of these type of perforated pots. We do find large number of pots in the Harappan levels. But now it is clear that these type of pots were used for making cheese and also paneer. Because we have studied the history of some of the pots, and we did find the history of the milk product in that. So we believe that they were used for that purpose. Then of course this yogic tradition was again introduced. Harappans developed a lot of scientific maybe health sciences for the common people. So meditation was one of them. Also yoga was introduced by Harappans. What you are seeing here, these are the terracotta figurines found from number of Harappan sites. And these terracotta figurines are in different yogic posture. You can see here. And India has a very long history of yogic science. And yoga science is perhaps the best gift India has given to the world. And the beginning of that goes back to the Harappan times. This is the earliest feeding bottle. We always thought that feeding bottle concept has come from the West. But this is, the Harappans developed this. What you are seeing here, these are the slates, writing slates. So even though we do not have direct evidence about the education system during Harappan times, one can infer that perhaps that they had proper organized education system during Harappan times. So we have the evidence of that. Also the Namaste tradition. The entire world has realized the importance of Namaste tradition during the pandemic. And that goes back to the Harappan times again. So these are number of different customs, traditions that were introduced by Harappans. Even this story, the thirsty crow, this is the depiction of that from the site of Lothal. So these type of stories have been composed by Harappans, and they continued from Harappans till modern times. When I visited Harappa, I saw this in a cage in the museum. And when I came out, I could see one person, in fact, carrying this cage. So this concept again is typical Harappan, and it has continued. The pet dog concept, this is the evidence from the Harappan level at Rakigadi. Then number of scenes, probably the concept of maybe trademark was introduced by the Harappans. Some of the scenes are related to the trade. Even some of the games were introduced by the Harappans. A tub concept. A mother is giving bath to bathing her child here. So these are some of the important traditions and evidence we find. The Harappans were at a disadvantageous position. They did not have sufficient raw materials within the Harappan region. So they had to import the raw material from different sites, which are located outside the Harappan region. They had maybe one proper workshop at Harappa, even at the site of Dholavira also we find that here. And there are a number of sites in Kutch part of Gujarat and also in Saurashtra, which were devoted for the manufacturing purpose. So we do have evidence in fact in that respect. And what the Harappans did, they did not have sufficient raw materials. So they developed contact with the contemporary population outside the Harappan region, who were controlling the maybe cheap important raw materials. So through the good relation, they could acquire the raw material. The Harappans had technology with them, and they used to make those finished goods And they used to supply the finished goods to the same people from whom they used to acquire raw materials. And this is very, very important. Because of that, Harappan used to flourish. And I always give the example of Japan. Right? Japan was destroyed in the Second World War, but Japan became a world economic power within 15 years. In 1950s, Japan was completely destroyed. In 1964, they showcased the tremendous progress that they had made in the field of economics. And the pattern that Japan followed was exactly the same as the Harappan pattern. Japan had technology with them, but they did not have the luxury of having basic raw materials with them. So they started importing raw material from India, China, the developing countries. They made goods on large scale and started supplying them to the same people, same countries. That is how Japan became a world economic power. And we have the example of that in the Harappan level also. These are some of the means of communication with the hinterland communities. And then, how this knowledge was transmitted. In India, we have very strong oral tradition. I was excavating at Rajasthan in one of the sites at Rajasthan. And one fine morning, we had one gentleman. So out of curiosity, I asked him what he does. He said that, he does nothing. He illiterate, but he can recite the genealogy of the royal family for 800 years. He was illiterate, but he could he could do that because, he has very strong, this sense of power. So through the tradition, maybe it was carried forward from generation to generation. And then, when the earliest universities were established, India, the credit of earliest universities goes to India. We have Taxila, which was established maybe 4th century CE, and then Nalanda around 5th century BC. So there, in fact, know that most of the Indian traditional knowledge was taught to the people. And people from different countries, we have records, they used to come here to learn the Indian knowledge system. So it was so relevant and so useful for the entire world that they used to come here. And then, of course, I come to the last part of my lecture, that is who are the people who have developed this basic knowledge, or what we call as the Indian knowledge system. There are a lot of debate in fact. Some people say that these people came from outside, some say that no, they are indigenous people, but we had no scientific evidence. So therefore, I started gathering the scientific evidence. In 2006, I started excavation at Parmana, and I excavated the largest cemetery at Parmana. Nearly 100 burials were excavated there. And one of our aims was to, if we want to understand about the people, maybe we should get the DNA of the people. So we tried from 2006 to 2010 at this particular site, but we miserably failed because we were not really ready for this new research. We did not know what kind of precaution we need to take. And therefore, we miserably failed that time. But then I came in contact with some Korean scientists, and they suggested that you have to change your maybe methodology. You have to, take proper precaution. That is how we started doing that. And then, of course, before the excavation, we took this type of precaution because our DNA can get into ancient DNA easily. And it was difficult to separate ancient and modern DNA because of that. First thing that we did was we took this type of precaution. He's not a corona warrior, but he's a burial warrior. You can see here. And yeah, this is the cemetery at Rakigadi, roughly 1 kilometer away from the settlement. And here, all of us, most of the work, in fact, this type of dedicated work is done by us only, by teachers and students. So we started excavating by taking this precaution. We made sure that the same instrument, digging instrument, is not repeated for the next burial to prevent any kind of contamination. That we did, and this was very, very successful. The mistake that we made at Parmana was that we excavated all the burials and kept them open for 2 months. So, there was rainfall, a lot of sunshine. Because of that, maybe whatever was there, it had completely gone. So we were, it was suggested that now target one burial at a time. So we started that, that particular method. We excavated, burial one at a time. Immediately we documented the burial, and then immediately we transported the samples to Deccan College laboratory. And because of that, we could succeed in getting DNA. So this is the kind of evidence we find. We do find, the burial goods vary from burial to burial, giving some indication about the social status of the person or economic status of the person. So we also did a lot of, sampling. In fact, the Korean scientists, they also have developed the ancient or the paleoparasitology science also. They have extracted some parasite eggs from the ancient bodies. And from the parasite eggs, they could identify the DNA of the person. So we also wanted to see whether we can get parasite eggs from the, Harappan burials, for which, we did, very extensive sampling. Of course, we did not find any. But then, the samples were carefully packed at the site. And when they are brought to the laboratory in Deccan College, same precaution was taken, making sure that, there is a, maybe proper precaution, prevention of, the modern DNA is very, very important. And then, what we did, in fact, when the samples were transported to Deccan College, we did, anthropological examination. We studied that, we completed, and we published that. Then we did, the CT scanning. I'll show you why the CT scanning was done, mostly for the reconstruction of the facial features. So that is called the craniofacial reconstruction. Again, that is the research for the first time done in fact in Indian subcontinent or in South Asia. And then, of course, paleoparasitology was tried. We could not succeed, but we'll continue doing this particular research also. And then, of course, sampling was done for the ancient DNA analysis. And then, of course, we carried out a host of various scientific analyses for understanding maybe the health of the people, diet of the people, and we could get a lot of information because of the application of all these different scientific methods. Without these methods, it is difficult, but we cannot really understand. So what happened in fact at Rakhigarhi? We excavated 60 burials. We examined all those, investigated all the burials. We did not find the, DNA in almost 59 burials. And we were about to abort, in fact. We thought that we would never get burials from ancient site. Sorry, DNA from ancient burials. And then we saw the lady who came to our help, in fact, the lady luck for us. So this was the last burial which was examined. And here, in fact, you can see the lady was probably from a affluent family, because on the basis of the material burial goods, one can, suggest that. And also she was beautiful because she has very sharp features. So like a modern day Haryana woman. And then, of course, we extracted the DNA. We published the first paper. And the title itself suggests an ancient Harappan genome lacks ancestry from steppe pastoralists or Iranian farmers. We had, lot of, argument about that, whether this, Central Asians came here or the Iranians came here who started farming, etc. And this research was recognized by the International Conference on Genomics, the biggest organization in genomic field. And they had identified 9 breakthrough researches, and Rakhigarhi research was one of them. So scientifically, this is accepted by the scientific community. So this was very, very important. I'm not going to go into detail, but one thing that is emerging from the study is that our ancestry goes back to 12,000 years, 10,000 BCE. We have used the this genetic chronology for for establishing the beginning of that. So around 12,000 years ago, you can see that 10,000 BCE, the hunter-gatherers broke into 2 groups. One went to Iran, and they got mixed up with the Anatolian people there, and the other group came to South Asia, and that group started developing its own very distinct ancestry. So that was happening, and then we see that maybe at some stage, maybe around just before the Harappans, a distinct, South Asian ancestry was developed. So that ancestry continues in the Harappan people. And from Harappans to modern times, it continues. All of us, from Kashmir, Ladakh to Andaman Nicobar, and from Bengal to Afghanistan, most of us are carrying 25 to 30% Harappan genes. No matter what religion we follow, what caste or creed we follow, but we own nearly 25 to 30% Harappan genes. And the rest are all mixed. Right? We have maybe 2% or 3% Iranian genes, maybe 5% Central Asian genes, etc. Because right from the beginning, people had a contact with different regions. So a lot of mixing was happening right from the beginning, right from 7000 BC. So that was happening, in the Indian subcontinent. So that is the evidence, which is very, very important. We also did, this. Yeah, we also, compare this Harappan DNA with modern samples. We had analyzed nearly 3,000 samples from different parts of South Asia, and this is the region right now from where we analyze those. Then also we compared this site called this Gonur in Turkmenistan, and this site called Shari Sokta in Iran. Both of them are contributed to the Harappan sites. And from the excavation, it was clear that there was some Harappan material there. And we also found some Harappan genes present in the population there, but not their gene in the Harappan population. That means the Harappans first began to go out, and then of course there was a reciprocal movement happening after that. So this is a very, very important. The Harappans were not the only people that time. There were a number of maybe contemporary population, on the eastern periphery and the western periphery of the Harappans also. And they all, in fact, know that how the Harappan ancestry has started moving from Harappan region to different parts. So from Harappan region, it went to Ganga Basin around 6005 BC. From there to Rajasthan, in the Mewar region of Rajasthan around 4500 BC. And in the rest of the country around 3000 BC. This is how the spread happened in the Indian subcontinent. And this is supported both in fact by genetic evidence as well as by archaeological evidence also. And here you can see in fact that slowly, it was moving, towards, this part, from there to this part, and then the rest of the country. And all of them, except Tibeto-Burman group, most of these people, they are the descendants of the Harappans. And then the question that you'll ask, why people look different. Some people have different color, different structure. That is mainly because, not because of the genes, not because of the DNA, but because of the maybe geographical factor, climate, or the food habit, and the mixing with with different population. Depends on that. Yeah, perhaps South Asia is the so it's considered the ethnic museum, but we have the highest number of variation. And the last part of our research is that now we have reconstructed the facial features of the Harappans. For the first time, we have shown one male and one female, how they look like. And this was also, we did use, the previous one, of course, was the Harappan boy, maybe around 18 to 19 years old. So we have done the reconstruction of the boy. And also the Harappan woman. Okay, so now to reconstruct this facial feature, we need two kinds of sets of data. One is the matrix data, the measurement of the bones, which we did at the site itself. And also we need this inner anatomy also. So that this data is very, very important. So generated through this scientific research. And then of course step by step, the reconstruction was done. And this is how the Harappan boy looks like. This is the first stage of reconstruction, facial features. First time we are showing this. And this is the reconstruction of the Harappan woman. And in terms of appearance, they do not differ much from the modern people of Haryana. human impact, the typical, the modern and the Harappan woman, they look alike. So we have three sets of data now. The archaeological data where we can clearly see the modest beginning and gradual growth, indicating the indigenous development. Similarly, we have the data, genetic data, which also indicates the indigenous development. And finally, this complex and differential features, which also suggest the continued Harappans in modern times. And of course, we do a lot of the public archaeology also because we want to make sure that the sites are not destroyed by the people. They are properly educated. And this is the biggest, important exercise that we started. And it is giving us, good. So thank you very much. I'm sorry, maybe I've taken more time.
Thank you, Professor Sinde, for your illuminating talk. So, because of the shortage of time, I think one or two questions.
Sir. Okay. The old civilization. That's so. Some basic structure. For example, the
To ask you a question.
so, right, for example, sort of some sort of part of the so that what might be the I think say where in the initial stage only I say that the teachers make sure that our education system is started and they impose new education system on us. That is primary the British education system or the European education system. Because they had realized that this is a very, very robust system. And if it continues, perhaps difficult for us to control these people. But that's what it was. So because of that, they did this system. But now the government has realized that a lot of very different systems. And if you want to really again become a leader right now in the world, then we have to bring back the ancient system also. But here, I have the government and everything that we should not discard the modern system, but integrate modern and ancient system. And then perhaps now we'll be able to do some innovative research and some new ideas will certainly emerge. So now government is taking proper steps in that direction, and I'm sure that that will happen soon.
Last question. Short.
It's the Harappan civilization disappeared suddenly between each dot and the previous speaker said, and after that there was a long gap. So when civilization started again, it was everything reinvented unless the Harappan people wrote books on engineering or something like that that we could be. There is a evidence of books.
See what the new research that is done now that clearly indicates that the climate of the pillar, because now we have data from different parts of the world, and that data is indicating that around 4000 BC, sorry, 2000 BC or 4000 BC, the climate was becoming dry and that was a global phenomenon. That time, most of the civilization began to collapse, and also the Harappan civilization, because the core region was not supporting agriculture. So gradually people are started moving to all different parts. And the peripheral area was already occupied by the continuing population. So they got mixed up, with those people. In fact, some of them went to Ganga Basin, some came to Central India, to Deccan region also. There were already early farmers there. So they got mixed up with that. And that is how they continue the knowledge system that they had over there. And then, as I mentioned that, that it continues from generation to generation. Even Kautilya's Arthashastra, if you read, most of the ideas, they are already reflected in the Harappan levels. So maybe, he read some, he got some ideas from the traditional knowledge system, and then he wrote that book. So once the, university, this university system was, introduced in the country, like, Textile University, Ananda University, then this knowledge system was, was taught properly in the education system. So that is how we continue. And then the knowledge has remained there because when, the time came for the second urbanization, people had idea that this is how the urbanization can develop. So it did not take much time in fact. For Harappa, it took almost, 3,000 to 500 years in fact to develop from the rural life to urban life. But in the second urbanization, it happened maybe in 2 centuries because knowledge was already there. People like use that knowledge.
Thank you very much. Okay. Yeah. Thank you very much.
It's a pleasure.
Give 1 second.
Thank you so much. The lectures were like revisiting the streets and parts of the ancient times with a different scientific perspective. Thank you so much. Now we shall move on to the verification of speakers. I would like to invite Professor Anindya Sarkar and Dr. Sarvajit Pal, Chairman of Azadika Amrit Mahotsav Organizing Committee for VECC, to join us on the stage. I would request Dr. Sumit Som, Director VECC, to felicitate Professor Anindya Sarkar and Professor Vasant Shinde with HBNI student Chandra. Thank you, sir. Those who are connected with Bengal by any means know the sentiments towards Maa Durga in this region of the country. The same sentiment is attached to an age-old handicraft and presenting here to the speakers as a token of appreciation. I would request Director VECC to present the idol of Maa Durga made with Chokra craft, Professor Sarkar and Professor Shinde. Dr. Sarvajit Pal is requested to present memento Professor Sarkar and Professor Shinde. HBNI student Pal. Thank you, sir. Now I would like to request the dignitaries on the stage to take their seat in the audience. Dr. Tilak Kumar Ghosh, convener of today's event, is requested to deliver the vote of thanks.
We are already late, so I'm going to give the vote of thanks. It will take 2.5 minutes. Honorable Director Dr. Tom, our invited speaker, Professor Sarkar, Professor Shinde, their colleagues and their family members, their students and postdocs, ladies and gentlemen. It's my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of the VECC Azadi Ka Amrit Mahotsav Celebration Committee, extend a very hearty vote of thanks to all of you for your precious presence today. At the very outset, we start thanking our director, Dr. Som, for chairing the session, and also thank you, sir, for giving opportunity to bring a festive environment in the campus. We appreciate your support and encouragement.
We are delighted to have with us today Professor Anindo Sarkar of IIT Kharagpur. Thank you, Professor Sarkar, for taking us in the quest for the hidden past of the Harappan city that we read in school books and telling us about the fate of climate change. We must mention our deep sense of appreciation for Professor Singh, who just illuminated us about the genesis of the Indian knowledge system and Harappan civilization. I would like to take this opportunity to place on record our hearty thanks to Saha Institute of Nuclear Physics for the perfect logistics support, all the staff of auditorium management, SNP Security for their cooperation with the organization of this event. Well, ladies and gentlemen, you may be aware that Azadi Ka Amrit Mahotsav is celebrated throughout the weeks, and today is in the third day. And for the celebration of today's event, a subcommittee chaired by Dr. Boishali Naik and backed by a team of one team of Navira Chivikash, Parthavashkar, Saurabh, Shilita, and Convoy. I thank all the members of the organizing committee as well as the full organizing committee of AKAM. We also thank the chairperson of the AKAM organizing committee, Sharbati Pal, and co-chairperson Subhasis Chattopadhyay, and of course, Boisha Devi, who did enjoy organizing the event and as a supervisor. We thank VCC security staffs, VCC accounts, administration, VCC transport section, particularly our canteen staffs. We thank our garden team. You must have seen the Rongoli just outside. And I just want to mention that our electrical section people who have illuminated our center literally putting the best image. You can just see how illuminated our center is. We thank all the students and visitors. I really appreciate that we came from different part of the city and sitting here. I also invite you that if you can attend the next program. Just before concluding, let me tell you that in this part of the country, particularly in Kolkata, which is called the cultural capital of the country, no event can be enjoyable without a cultural program. So we are delighted to present a folk band Madhur, who will be performing just after that. I would like to thank in advance to them. So that brings me to the end of the proposal for vote of thanks. Thanks to all of you for your precious presence today and enjoy the evening.
थैंक यू तिलक दा। आपने सभी को धन्यवाद दिया। ऑर्गेनाइजिंग कमेटी की ओर से आपको भी धन्यवाद। यह सत्र यहीं समाप्त होता है।
हेलो हेलो
हॉल में आप सभी से फिर से अनुरोध है कि आप हॉल में बैठकर मत खाइए। इस हॉल के अंदर बैठकर कुछ भी खाने का सामान खाना मना है। कृपया इन बातों का ध्यान रखिए।
হ্যালো সকলের কাছে একটা বিশেষ অনুরোধ, আপনারা দয়া করে হলের ভেতরে বসে খাবেন না, দয়া করে হলের ভেতরে বসে খাবেন না।
Ladies and gentlemen, ladies and gentlemen, a very good evening and warm welcome to all of you to the cultural event of DAE Iconic Week, which is being celebrated as a part of Azadi Ka Amrit Mahotsav. Today afternoon, we revisited the glorious prehistoric era of India with scientific explanations from the lectures of eminent scientists and archaeologists. And now we shall cherish and absorb the vibes of the Indian folk songs. It is being presented by Madhur, the famous female folk band. The word Madhur represents a traditional folk musical instrument, treasuring the elegance of age-old music. Mentor of Madhur Group, Dr. Tapan Roy, described this group as a concept of folk music, presenting the various aspects of life of rural women.
माधुर, यह संस्था भारत के गांव में रह रही उन महिलाओं के प्रति सजग है जो एक लोक संस्कृति को अपने आप में समेटे रहती हैं और पीढ़ी दर पीढ़ी उसे बचा कर रखती हैं अपने आने वाली संतति को देने के लिए। उनकी हंसी, उनका रुदन, प्रसन्नता, दुख, दर्द, मिलन, विछोह सब कुछ छिपा रहता है उनके लोकगीतों में। भारत के पूर्वी भाग में इन लोकगीतों की एक बहुत लंबी सूची है। उदाहरण के तौर पर भवैया, हटियाली, झूमुर, धमाइल, मुर्शिदी, मारपती और भी कई नाम। किसी लोकगीत को प्रस्तुत करने की कला लोक संगीत का सबसे महत्वपूर्ण भाग होता है। इस लोक कला के क्षेत्र में श्री दिनेंद्र नाथ चौधरी एक लब्ध प्रतिष्ठित नाम है। उन्हीं के एक प्रतिभावान शिष्य डॉक्टर तपन राय ने लोक संगीत के कई संस्थाओं की स्थापना की है, जैसे मादोल, मुक्तधारा, सहजात्री, लोकायत, बोहिराना इत्यादि। इन्हीं में से एक मादोल समूह आज हमारे बीच उपस्थित है और बहुत ही प्रसन्नतापूर्वक हम आप सबके बीच प्रस्तुत करने जा रहे हैं मादोल समूह के लोकगीतों को। आप आनंद उठाइए गीतों के माध्यम से भारत के गांव में रची बसी हमारी पारंपरिक लोक संस्कृति का।
Good evening, ladies and gentlemen. Now we are going to present the title song of Madhur. The title song has been written by eminent lyricist and singer Sri Qazi Kamal Nasir, and its tune has been written by our mentor, Dr. Topun Roy. Through the title song, we try to express our work related to women empowerment. Presenting you the title song of Madhu. The song Nachite Nachite. This is a song of Hawaiian Ondo. The music has been popular through the eminent folk singers Srimati Pratima Barua and Sri Nirmalendu Chaudhary. They had their own style of singing. And by considering that particular style, we are presenting to you this song in our own unique way. Presenting you Nachite Nachite. Now they took that photo. But earlier, the brides were beautifully dressed up by the women in the house who used to sing songs of praise and made the makeup of the bride with love and affection. While singing, dancing, and their daughters are decorated with gold, silver, and gold. One thing would be we not mention that this particular song was first collected by renowned Our mentor, Dr. Topun Roy, a big round of applause for him. Our crown partner, a big round of applause for them. Rajashri Crown and Dr. Shubh, the director, Renewable Energy Hackathon Center. Dr. Sharbojit Kaur, Dr. Oishani, Dr. Vinod Ghosh, and all the members of the organizing committee of Azadi Ka Amrit Mahotsav for your cooperation. Madhav. Yes, Ravi. Sure. Saya akan bertipu.
I'd like to come on the stage, Professor Dr. B. Professor Kitpa here. Your TV has